Let's talk about our black hole. Wait, that came out wrong. Let's talk about the central black hole in the middle of the Milky Way galaxy, Sagittarius A star. The black hole that was officially discovered back in 1974 by Bruce Balich and Robert Brown. But they didn't really know what this was because all they saw was an unusual radio source. The radio source that they basically named Sagittarius A with a star denoting something really exciting in the middle. But eventually our telescopes got sensitive enough that scientists could now observe the orbits of stars in this region, and so by observing the stars for years and years, they definitively confirmed that there is a black hole here, and its mass is approximately 4.3 million solar masses. The discovery that eventually led to the Nobel Prize in 2020. But since then we had so many other discoveries about this region and about the black hole that actually keep surprising scientists pretty much every year. And we just got another discovery about this central region, in the process discovering that there might be something very extreme orbiting very close to it. And so, hello wonderful person, this is Anton. Let's discuss the central black hole once again, talk about these recent announcements, and briefly mention other important discoveries from the last few months. Although just as a reminder, it's only been just over a year since this image was finally released, physically showing us what's going on around the black hole, as a lot of activity around it was captured in radio light. Now here of course we see the shadow of the black hole, and also a few regions that seem to be slightly more active than other regions. Although in this case this is not a true picture of a black hole, because this is really more of an averaging of different shots, in some sense showing us a time-lapse. And in case you're wondering, here's how this image compares to the original image from the M87 black hole, in essence showing you how these two black holes compare in terms of size. Here Sagittarius A star is just a tiny pixel inside the M87 black hole. That's how massive this other one is. And interestingly, by using this image, we can now even tell the size of the black hole, and more importantly, the size of the accretion disk. Here, this disk measures approximately 52 million kilometers across, or about 1/3 of the distance of Earth to the Sun. So once again, here's how it compares to the orbit of Mercury. But once again, these are not optical images, because this just shows us radio waves. And the thing is, it's impossible to take an optical image of the black hole because of all of the dust in the middle. The enormous amount of gas in between the black hole and planet Earth essentially makes this practically invisible. You can only see this in certain frequencies such as X-rays, gamma rays, and of course radio light. And so pretty much most discoveries coming from here are usually in these other frequencies. And there have been quite a lot coming out pretty much every year. As a matter of fact, just a few months ago, we've discussed this unusual discovery of very strange radio filaments that seem to be directly connected to Sagittarius A star and seem to be streaming from it, extending all the way across the central region of Milky Way. As you can see from this image, there sure is a lot of them out there, but exactly what produces them is currently unknown. But normally, different types of radio emissions are associated with magnetic fields. And there definitely is something unusual about the central black hole compared to other black holes when it comes to these fields. For example, we know that based on the observations here, the average accretion rate of various types of gas into the black hole is unusually small for a black hole of this mass, as if something is preventing the gas from falling inside. And that something is very likely magnetic fields around the black hole that surround the gas and dust in this region, very likely funneling all of this gas into the orbit around the black hole as opposed to letting it fall inside, which in essence maintains a small disk around the black hole, but also keeps the emissions from the black hole relatively low. And that's actually one of the mysteries about this black hole. It's super quiet compared to everything else we know. Every other central black hole observed out there has been much more active, producing more energy, and definitely way more visible. But definitely not this one. And that's the mystery that nobody has an answer to. Nevertheless, despite the quietness, in the last few years, the black hole has experienced occasional flare-up, usually increasing in brightness in certain frequencies, normally X-rays, by anywhere from 70 to 400 times, but just for a very short period of time. It actually happened at least twice, back in 2015 and 2019, and it could have been caused by, well, really a lot of things. Maybe something fell into it, like a tiny asteroid, or maybe those magnetic lines snapped, releasing energy, or maybe some of the accretion disk got reshuffled in the process. But to solve these mysteries, a few years back, scientists were actually hoping to observe a nearby passage of an unusual gas cloud that was detected earlier that was supposed to show us what exactly is happening around the black hole as it was supposed to get, I guess, more active for just some time, as some of this extra gas from the cloud referred to as G2 was supposed to fall into the black hole. But the thing is, nothing really happened. The observations here were conducted, but even though the gas cloud seemed to have passed, nothing was activated and no additional activity was detected at all. And that was a little bit strange because it was definitely not what anyone expected. And so some scientists proposed that maybe this was not actually a gas cloud but some kind of a star instead, or maybe even binary stars that then sort of collided creating a larger cloud, or maybe this was something we just don't understand yet. Either way, at the moment there is no answer to this mystery either. And so we never really got to study the accretion disk or the environment around the black hole because nothing ever activated it to produce additional emissions. And because this black hole is relatively quiet and the accretion disk around it doesn't produce that much energy, it's essentially very difficult to observe anything here. But some emissions were actually coming from here and discovered completely by accident. And first this was found in the X-rays. By using the data from NASA telescopes, researchers identified an unusual periodicity that seems to be visible in the X-rays. And here something happens every 149 minutes. It wasn't really clear what this is first, and it wasn't actually clear what's even causing this, but it was a very interesting discovery. You can learn more about this in one of the papers in the description. And then, just last year, an extremely similar observation was found in different frequencies, this time in radio waves. Here, by observing radio waves, and specifically looking for patterns, researchers discovered that something seems to be causing very periodic radio emissions approximately every 76 minutes. Which actually adds up to being half of the other emissions that were detected a few years before. And the proposed explanation was basically something like this. There might be something in orbit around the central black hole, somewhere at the edge of the accretion disk, essentially causing these emissions as it goes through a certain point inside the accretion disk of the black hole. And so if we had the observations in the X-rays and the radio waves, and they seem to have some kind of a connection, other scientists assume that, okay, maybe we can look at this again in a different frequency and discover something similar as well. And that's exactly what the scientists behind the very recent paper did by looking at this with the Fermi telescope and by analyzing the gamma ray data. And specifically, once again, looking for periodicity or some kind of a repetition, some kind of a pattern. And as the title here suggests, there is one, and it seems to be exactly the same. With all of this data confirming that there is definitely something in orbit here, and that something is definitely causing the emissions because it's orbiting around the black hole at approximately 30% the speed of light. And so by moving so fast, it very likely has dramatic interactions with whatever is here, such as the gas in the accretion disk, producing all sorts of frequencies, anything from radio waves to, of course, gamma rays. Although because the X-ray flare has a periodicity of 149 minutes, here the scientists propose that it's probably some kind of a harmonic of the gamma ray and radio periodicity. And so the fact that we're seeing different frequencies of light with exactly the same period only raises the next question. What exactly is this? In the older paper, it was assumed to be some kind of a really dense, really hot gas, or some kind of a clumpy region that seems to be stuck there that potentially creates these effects. But if this is gas, why is it not falling apart? And once again, the initial assumption was that maybe there is a very powerful magnetic field around it that sort of holds everything together. And it's actually very likely the magnetic field emissions that seem to produce some of this periodicity, specifically observations in the radio light. But that would not explain the gamma rays, or at least would not explain them very well. Although I guess here, gamma rays could be produced because this stuff is moving ridiculously fast, nearly 100,000 kilometers per second. And so here it's possible that as this strange blob, or whatever this is, moves around the black hole, it emits energetic flares when it has the interaction with the accretion disk at some point. And it's also possible that all of this is due to the change of temperature. It might get heated up and cooled down, depending on where exactly it's located, which could then explain why we're seeing more or less radio waves coming from this region. Either way though, whatever this is, it's probably one of the biggest mysteries in the central region, and is definitely some kind of an object we still don't understand. I mean, for all we know, it could be something entirely different, like a magnetar. There was actually one discovered back in 2013 that flared up as it approached the black hole, but this one was not in orbit, and so maybe this one is. Either way, at least for now, this is going to remain a mystery. So before I start this video, I wanted to show you this picture right here. This is literally the picture of our sun. And this is an extremely important picture that shows us a solar spectrum. It basically shows us tiny absorption spectra of various elements in the atmosphere of our Sun. Every little black line you see, that's a result of some kind of an element, such as, for example, iron, sodium, potassium, calcium, or oxygen even, absorbing the light and producing these black lines. Now, the reason this picture is important is because by doing this on a much grander scale, we can then start seeing this in a lot of stars in the Milky Way galaxy, in essence allowing us to learn about their evolution and potentially find siblings or partners of various stars. Today though, we're going to discuss a new discovery of a very strange star that doesn't just have a very good explanation to why it is the way it is, but also potentially creates a major problem for what we currently believe about supernova and about various massive stars exploding in certain ways. And so, hello wonderful person, this is Anton. Let's discuss this very strange star and its unusual origin, find out why it's so unusual to begin with, and more importantly, learn about what this means for modern cosmology. But first, a super short review of what we know about star formation and supernova. When it comes to the evolution of stars, we know that over time stars generally accumulate heavier and heavier elements. And that's because initially, stars mostly contained hydrogen and helium, but during a supernova, an intriguing process known as the R process forces lighter elements to become heavier and basically forms every other element in the table of elements. And though some of the heavier stuff requires additional processes, such as, for example, collisions of neutron stars, for the most part, a lot of heavy elements can be formed through various star explosions, with additional supernova over time basically enriching further generations of stars with heavier and heavier stuff. And that's in essence our Sun. It's a population 1 star that very likely was formed after at least 40 different supernova in the past that dramatically enriched it in a lot of different heavier elements that usually astronomers simply refer to as metals. But that's of course a simple explanation. It does get a little bit more complex depending on the actual supernova and even the shape of the supernova. For example, if it's not perfectly aligned or if it's not perfectly spherical, it's going to release certain heavier elements into one direction and not the other direction, which will of course influence the evolution of future stars, with more extreme examples of various supernova remnants potentially producing more extreme examples of stars. And though we generally understand how all of this works to some extent, there are still a lot of things that nobody understands just yet. And so in the last few years, some stars have been discovered to contain somewhat unusual elements or potentially ratios of elements that did not make sense right away. And though most were explained to some extent, that's not the case for the star we're talking about today. So here's what it roughly looked like back in 1999. This is not a new star, it was actually known to us for over 2 decades, and it's known as J0931 plus 0038. And it's a relatively close, low-mass star that's believed to be population 2, or basically the second generation star after the existence and the explosion of early stars in the early universe. This star is also not really in the galactic disk, and is currently located in what's known as the galactic halo, a region around the galaxy where we often find a lot of ancient stars, which also makes this particular place a perfect opportunity to try to study the evolution of galaxies or to try to understand how galaxies and the universe itself evolved over time. But normally most stars found here contain relatively primitive elements. They'll obviously contain a lot of hydrogen and helium, but also some of the more simpler elements such as sodium, carbon, oxygen, and maybe aluminium. There's not going to be a lot of complexity in these stars, but they will contain some stuff. Once again, a result of these super powerful supernova in the early universe. The events that we actually know very little about because these first stars have never been detected or seen anywhere. We usually call these stars population 3 stars, and you can learn more about this mystery in one of the videos in the description. And so one of these stars, roughly around 13,000 light years away from us, caught the eyes of astronomers, and mostly because of its unusual elements. Very unusual elements. It seemed to contain stuff that we've never seen anywhere in these proportions. For example, it didn't contain a lot of sodium or aluminium, but it was very rich in iron, nickel, zinc, and even strontium and palladium. It basically had all of the stuff that we've never seen in most of these relatively ancient stars, and especially in these super strange proportions. Now, it might not sound like super important, but it's actually really important because it basically suggests that this star was created from a very different molecular cloud. a cloud containing elements that we've just never seen anywhere before, as if it was created by something really strange. And the cloud that this was made from contained extremely different elements from literally every other cloud we see. For example, strontium and palladium abundance makes no sense whatsoever, with the overall abundance graph resembling something like this, with the only possible explanation being very unusual supernova. A supernova that occurred billions of years ago that for some reason formed elements in a different way from what we expect or from what we've seen so far. And even though the star has been known since 1999, it's only because of recent observations in more color that all of this became apparent. The star was very low in carbon, very low in sodium, very high in iron and zinc, with the only proposed explanation that currently makes sense being an extremely specific type of supernova we never thought was possible. A supernova of a very massive star with a total mass of about 80 solar masses. But today we know that this should be impossible. A star of 80 solar masses should not explode. Modern calculations suggest that it should just become a black hole by just collapsing into one without any major explosion. And that's because when it comes to supernova, they're generally divided into several major categories. For example, a white dwarf of a certain mass is going to go through what's known as a type 1 supernova, in this case leaving nothing behind. Stars of about 10 to maybe 25 masses are going to go through iron core collapse supernova, but overall be somewhat faint compared to more massive stars that can generally even end up in hypernova or produce a gamma ray burst. And these will usually produce either a neutron star or a black hole as a result, with more recent studies even physically finding evidence for black holes or neutron stars left after major supernova. But with more massive stars, things become more complicated. They should either just collapse, maybe producing a gamma ray burst, but no major explosion otherwise. Or, if they become really massive, they can explode completely, leaving nothing behind through the process of pair instability supernova. But there is this gap in terms of mass of stars, where we do expect the star to just basically become a black hole with no supernova produced whatsoever. And that's also why we generally don't find a lot of stars with masses over 50 solar masses, except for maybe some exceptions here and there. It's because these stars seem to just basically kind of collapse, disappearing in the process. And this is what we expect from a star with a mass of 80 solar masses. Yet the only explanation we have right now for the star detected in the Milky Way is basically a supernova of a star with 80 solar masses. And so at the moment, there is just no explanation to what exactly is going on. Yet a supernova of this type of a star does explain a lot of these unusual elements present here, because here it would essentially be a somewhat metal-poor source of elemental production that did not produce a lot of things like sodium, but produced a lot of heavier elements due to the power of the explosion, with that particular star potentially even being one of the first stars in the universe, the elusive population 3 stars. And so through this process of stellar archaeology, the researchers here identified something we never thought was possible. As a matter of fact, here they actually calculated the explosion itself, and it could have been so powerful that it would technically have enough power to blow up a smaller galaxy. And so if this was inside a dwarf galaxy, this galaxy would no longer exist. But if correct, this also implies we should be seeing more of these stars, because it's quite likely this nebula produced a lot of neighbors. And so if we can find more of these unusual second generation stars, this would provide evidence for this hypothesis, while also providing evidence for unusual supernova that a lot of these first stars must have gone through. And yet again we have a new mysterious object discovered relatively recently, completely by accident. An unusual astronomical object you see right here. But in this case, it's actually even the name that's strange as well. The researchers behind this paper decided to name it Draculas Chivito. Now I actually had to look up what chivito was. Turns out it's a very popular sandwich in Uruguay. Kinda looks like this. And though I guess maybe there is some resemblance, yeah, Dracula's sandwich? Okay. Hello wonderful person, this is Anton. Let's discuss this mysterious object, what exactly we think it is, and actually talk about why this particular discovery is really important. It confirms an existence of an entirely new type of an object we've only seen before once. And so let's actually start with that, and I guess a bit of history. And it all starts with Infrared Astronomical Satellite, very often referred to as IRAS. the telescope that was responsible for creating the first ever infrared survey of the entire night skies. And this actually started back in 1983. And during its relatively short mission, it was able to discover a lot of different objects. For example, it discovered this unusual nebula you see right here. And actually was so successful that it eventually led to additional telescopes and then eventually led to the James Webb. But during its initial mission, one of the objects it discovered kind of looked like this. It resembled something we haven't seen before, at least back then. But then additional images taken by Arturo Gomez from Cerro Tololo Inter-American Observatory in Chile revealed additional features from the object that was previously only seen in the infrared. And I guess because maybe he was hungry or something, eventually this became known as the Gomez's hamburger. That's actually literally the name of this object. And though it might not resemble a hamburger that you and I used to, nevertheless that particular nickname stuck, and for many years it was believed to be some kind of a very strange nebula, possibly thousands of light years away from us. But that's until 2008, something like 25 years later. Additional analysis using additional telescopes, and especially the analysis of this unusual dark band in the middle, revealed something that was invisible at first. This was not a nebula. Instead, the research you can find in the description revealed that this is basically a type of a baby star. Something we very often find in a lot of different molecular clouds, and something that we've seen many times before. Possibly somewhat similar to this, a few Orionis, but very likely much larger, much more massive, much more active, and definitely more extreme in a lot of other ways. And so essentially this was a type of a protoplanetary disk, but a disk seen from a different angle, and thus appearing to us from a different perspective. And so essentially we're looking at this from the side. And so because of this unusual band in the middle, this could not be a nebula of any sorts. And so instead of this being a nebula 6,500 light years away from us, Gomez's hamburger turned out to be just a young star approximately 900 light years away. Much closer, but also really massive and really extreme. At least 4 solar masses, and containing a large amount of gas and dust in the protoplanetary disk. As a matter of fact, one of the main ways this was confirmed was essentially by observing different types of carbon monoxide gas moving in what seems to be circular motion around the center. And this Keplerian rotation basically suggests that this is a protoplanetary disk, very likely representing a star that's not main sequence star yet, it's not burning hydrogen yet, but is about to become one really soon, and will probably get rid of all of this gas in the process. But unlike a lot of other observations, it was also extremely hot, over 10,000 Kelvin. And so a lot of these individual features were very unusual and never actually seen before. But in this study, pretty much everything about this was now explainable, including the unusual reflection of the light you see as the white sides representing the buns of this hamburger, with the dark band basically being all of this relatively thick gas. Intriguingly, additional observations also revealed a potential protoplanetary object, something that was maybe similar to Jupiter, forming somewhere in a disk. But one of the most mysterious parts of this observation, and something that could never be explained before, was actually its location. Unlike a lot of other similar objects, this was not inside a nebula, not inside the molecular cloud, not inside anything. It was actually in the middle of empty space. In other words, this unusual star was actually forming by itself in the middle of nowhere, but also contained a huge amount of mass and a huge amount of material. But there was nothing within light years and light years away from it, including any molecular clouds or any regions of star formation. And so this was actually the biggest mystery. This strange hamburger was forming in the middle of nowhere through the process nobody could explain. And this was the mystery that stayed with us ever since the original discovery, mostly because no such objects have been ever seen again. Until now. And now we have that Dracula thing. The Dracula's Chivito, which I guess is a play on words from the Gomez's hamburger, which seems to be pretty much exactly the same. Very similar features, very similar observations, extremely similar temperature, once again thousands of degrees Kelvin, almost exactly the same orientation toward us, and what's even weirder, even relatively similar distance, 980 light years away from us, as opposed to just over 900 for the hamburger, but not in the same location at all. But once again, a lot of similar observations here do suggest that this is just a really massive protoplanetary disk of a relatively young A-type star. A really hot massive star that's going to become super powerful once it initiates hydrogen burning. And so by itself, this is a very intriguing mystery. We have these two almost identical objects in very different parts of the night skies, but containing extremely similar features we've never seen anywhere ever before. But there seem to be only two of them in the night skies. But because there are now two, this is very likely a new class of newborn stars. And we actually have no idea how any of this formed. Neither one of them has any molecular clouds nearby, any nebula, or any regions with star formation, and none of them seem to be moving from a location where stars might have formed. In other words, there are no stellar nurseries anywhere nearby. At the moment, we don't even see any gas-enriched regions from which these stars could have collected all of this gas, forming these really massive stars. Both of these objects seem to be basically in the middle of empty galactic space. And so that's really where the mystery begins and I guess kind of ends. Nobody knows what's going on here, but visually these do resemble a lot of protoplanetary disks, even the ones that were recently visualized by the James Webb. For example, compare this to some of the recent infrared observations from the James Webb, but in this case in the Orion Nebula. So in terms of visual description, they do seem very similar. Every one of these is a baby star as well, visible to us from a sideways perspective. And so it's quite likely that these are as well. But every one of these stars began their life inside a relatively dense cluster as a result of overdensities forming inside the molecular cloud. In other words, they began as a kind of a gravitational collapse of a lot of gas inside a somewhat turbulent environment, which then formed the unusual disks, made them spin more and more, and created a lot of additional formations, including the jets you see around some of them. But in order to form this disk, you do have to have gas with at least some momentum. So what exactly happened here? There's nothing around this. And so even though that hamburger was basically a mystery for something like 40 years now, because we now have two objects, someone might be able to solve this mystery in the near future. For example, by focusing on these extreme similarities, especially in terms of shape, size, and even the temperature, we may be able to find clues on how these formed and reached these incredibly large sizes and masses. For example, for this newly found object, it seems to be of the type that we usually refer to as Herbig AE type star, and it has an average temperature of 8000 Kelvin or 7700 Celsius, 14,000 Fahrenheit, which is really hot for a star of its age. And here the disk is also really large. It's approximately 1700 astronomical units in radius, or basically 40 times as large as the distance of Sun to Neptune, with a total mass of the disk being approximately 0.2 solar masses, meaning that it's going to end up producing a lot of large planets. And so all of this mass must have come from somewhere. But in terms of trying to understand this, and I guess trying to simulate this, what you're actually seeing right here is the image of the simulation and the observation. And so by modeling stellar formation, the researchers were able to create something almost exactly the same. And so this has to be some kind of a young star. But why these stars are isolated, that's the question nobody has an answer to. Although since two have now been discovered, chances are there are so many more around us. But going back to that original question, why Dracula though? At first, I actually assumed it was because of some kind of a vampiric property, such as maybe sucking matter away from a partner star. But it turns out that the actual reason is a little bit more, cheesy. Apparently, if you really squint your eyes right here, you can sort of see that there are unusual filaments that seem to be perpendicular to the disk, resembling fangs. Dracula's fangs. Okay, yeah, that's kind of pushing it. Anyway, despite the cheesy name, and that includes that first object, Gomez's hamburger, these are still really fascinating objects. These are definitely the closest regions to us with isolated star formation going on right now, and that's something that we don't really see much around, yet we have seen in various locations in between galaxies. And so maybe, by answering what's happening here, we can figure out how various stars can actually form without a molecular cloud. And so in essence, this is definitely a really important discovery, but a discovery that does not have a good answer just yet. Hello wonderful person, this is Anton, and today we're going to be discussing some of the recent discoveries in regards to some of the most extreme stars in the Milky Way galaxy. The stars referred to as hypervelocity stars. The fastest moving stars discovered in the Milky Way so far. Stars whose velocities are so high that they're actually going to be escaping the Milky Way as they're traveling across the galaxy. And this recent paper that you can find in the description below even discovered a new record holder, basically a star that's moving across the night skies at nearly 3,000 kilometers per second. And so let's talk a little bit more about this concept, talk about these new discoveries, but also discuss the unusual origin of some of these stars discussed in this recent paper. But first, I guess let's discuss the overall concept of the star velocities across the galaxy and how some stars acquire high velocities. So on average, most stars moving across the galaxy usually have a velocity of under 300 kilometers per second. For example, the solar system and obviously planet Earth move around the galaxy at just over 230 kilometers per second, which is a typical speed for a typical star located in the galactic disk. Obviously, in some locations, like globular clusters, the velocity is going to be a little bit different, because here objects orbit in a much more compact way. And in some cases, based on various supernovae in various molecular clouds, you also get what's known as runaway stars, which are basically stars that are located near some kind of a supernova and basically get kicked out from the system as the supernova occurs. This is kind of common around various nebula, and the iconic Barnard's Loop located in the Orion Belt is actually believed to be one of these ancient supernova that might have produced a few runaway stars. Here's another example from the Orion Nebula of what's known as the bow shock, produced by a fast-moving star as it travels through the nebular cloud. But on the extreme side of the spectrum, we also have stars that move really fast. These are known as hypervelocity stars, with velocities exceeding the orbital velocity in a typical galaxy. And that means that these stars will usually have velocities over 1000 kilometers per second. Although just to escape the Milky Way galaxy, you only have to travel at approximately 550 kilometers per second. But in this case, these stars will often travel at least at double the speed. And so because of this, it's of course assumed that these stars are going to escape the galaxy, or it's actually even been previously assumed that some of them might be coming from other galaxies out there. In other words, these are basically just visitors from other galaxies where these stars acquired very high velocities. Now, the first such star, whose name you see right here, and that's often referred to as the outcast star, was originally discovered back in 2005. But as soon as the scientists realized these stars exist, pretty quickly they started to find more as new techniques became available and as telescopes improved as well. Now, previously, just to measure the velocity of the star, the scientists would basically have to look at the star and its motion across the night skies for several years. Here's an example of the nearby Barnard star. And here the observations lasted for just over 20 years. Obviously, doing this for every star out there would be kind of impractical. But with advances in technology and new telescopes, the stellar kinematics, or advanced measurements of star motion, actually became relatively simple. And today we have a telescope that's extremely good at that, able to do so automatically pretty much 24/7, and has been doing so for many years. The iconic Sgr A telescope. And in the past it's already discovered a lot of incredible things that would be otherwise invisible to us or would take forever to find. But by analyzing the data from just the last few years, the scientists were able to find various anomalies where the stars were just moving a little bit too fast, naturally suggesting that they were hypervelocity stars. And so, for example, just 2 years ago, the scientists behind this paper have already identified nearly 600 high-velocity stars, with 43 confirmed to be hypervelocity stars, with the total number of these stars discovered going from like 20 to now almost 100. But even at these numbers, these are still relatively rare objects, considering the fact that there are billions and billions of stars in the entire galaxy. But the obvious question that the scientists always had about these unusual stars is, what exactly makes them move so fast? Is it always the supernova, or is it something entirely different? Now, one of the first such stars discovered, US 708, is believed to have been one of the first stars confirmed to be a result of a very unusual supernova that we're going to discuss in a few seconds. But over time the scientists realized that this seems to be kind of rare. The majority of these stars actually very likely are produced by entirely different means. And it's now believed that most of them very likely come from various binary systems that had some kind of an encounter with a supermassive black hole, possibly in the center of the galaxy, where one of the stars basically gets swallowed, the other one escapes. And because this is something we expect to happen in a lot of galaxies out there, it's not surprising that many of these different stars travel across the entire universe, very often passing through galaxies like the Milky Way, but many more traveling in the intergalactic space. We also have some examples of various neutron stars, like the one that you see right here. This is an actual image of one, that tell us of a different mechanism involving various supernova. At least one of these neutron stars has actually been discovered to travel at approximately 1500 kilometers per second. It's the object right here, sometimes referred to as the cosmic cannonball. But these are also believed to be somewhat rare and require extremely specific conditions. And because these are neutron stars, they contain more mass and thus require a lot more energy to propel them to very high velocities. But smaller stars technically can actually travel much faster. And so the scientists wanted to figure out if there are maybe, for example, white dwarfs or even smaller stars that could be traveling even faster. And so in the most recent paper, with a simple title, The Fastest Stars in a Galaxy, one of the main ideas was to actually discover these super fast stars that were probably created as a result of a very specific supernova. A type 1a supernova, which usually happens when a white dwarf explodes, but involving a partner that was orbiting very close to this white dwarf. And the way that this mechanism very likely works is very similar to how a typical nova works. We have a white dwarf and some kind of a different star that serves as a donor for the white dwarf collecting all the mass. Although in this case the scientists believe that it's probably two white dwarfs, with one of the white dwarfs being the donor. At some point that more massive white dwarf collects just enough mass to reach the Chandrasekhar limit of approximately 1.4 solar masses, at which point, according to modern physics, the white dwarf collapses and explodes. But in this case, this explosion seems to be very unique. The scientists refer to this as D6 supernova, dynamically driven, double degenerate, double detonation. And the reason it's different is because it's not actually collecting hydrogen from a larger star. Instead, it seems to collect helium, depositing the helium on the surface. And at some point that helium layer becomes so thick and so dense that it reaches conditions where helium fuses into carbon, but does so very violently. Now, in a normal white dwarf binary system, this is when we get phenomena known as nova. These generally happen all the time and we see them from everywhere, and these are actually very well understood. But in some rare cases, when the helium layer is just thick enough, it can trigger a secondary detonation of the core of the white dwarf itself, basically completely eliminating the star and creating this massive explosion right next to the other white dwarf. And that kick is enough to suddenly give this much smaller white dwarf a huge amount of velocity, producing some of the fastest moving stars across the galaxy. But this is a really rare event, and so what the scientists were trying to figure out was essentially how rare. Can we actually find more of these by searching through Gaia's survey, or have we basically found most of them? And then it turns out that they found 6 more runaway stars, with 2 stars breaking new records in terms of velocity. And so even though the previous record holder had the velocity of 2200 km per second, the new star, J0927, is moving at a velocity of 2753 km per second, with the second record holder having a velocity of 2670 km per second, or roughly around 500 km per second more than the previous record holder. But I guess interestingly enough, there's really only about 15 of these stars known across the entire galaxy created by this unusual supernova event. All other stars are very likely produced by the interaction with massive black holes. But these supernovae do create the fastest moving stars, so this is actually a pretty interesting discovery. Nevertheless, here the scientists are pretty convinced that this is just the beginning, and there are very likely a lot of dimmer stars that are still missing and are still hiding, especially stars with even less mass and thus less luminosity. Also, statistically, the scientists believe that our galaxy itself has already launched at least 10 million of these stars in the last 12 billion years. And if the same number came from other galaxies, we kind of expect a lot of them to pass through the Milky Way even right now. And because of the statistical analysis, the scientists strongly believe that there are quite a few of these stars, even very close to us, within solar neighborhood. But because of their dimness, they're just very difficult to find. But obviously discovering them would be really exciting, because these would be visitors from very distant galaxies, providing opportunities to study molecular composition of galaxies really far away. And so it's quite likely that these are just the first discoveries coming from the Gaia catalog, and we're probably going to find more in the next few years. But before we finish the video, I also wanted to quickly clarify that these are not the ultimate fastest stars in the galaxy. Because obviously the fastest stars are right next to the central black hole. Some of these stars move at velocities close to 20,000 km per second, but they only have these velocities when they're basically extremely close to the black hole itself. You can learn more about these stars in one of the videos in the description. But when it comes to the overall fastest stars just moving across the galaxy, the stars in this paper are currently the fastest we have. And so following this discovery, it's quite likely that the new discovery is going to be in regards to fainter objects that were either previously missed by surveys or were actually just invisible to us until relatively recently because of the advances in telescope technology. And so at some point, I'm sure in the next few years, we're going to have a discovery of a star that's moving over 3,000 kilometers per second, or maybe even faster. In one of the previous videos, we've briefly discussed one of the most groundbreaking announcements when it comes to cosmology and astrophysics of 2023. The announcement for the detection of very unusual gravitational background noise that seems to be caused by something really massive. That video is obviously in the description below. But on that same day, a completely different announcement was made by a completely different team and was also to some extent somewhat groundbreaking. But one announcement went viral, the other one sort of disappeared into obscurity, receiving almost no press time. As a matter of fact, most of the press didn't really do a good job explaining what exactly was discovered, even though it was actually pretty groundbreaking as well. Hello wonderful person, this is Anton. So today we're going to be discussing that last viral announcement announced in late June of 2023 in regards to neutrinos, and specifically in regards to this. Now before I explain to you what this is, let's check out one of my most favorite websites created by Nick Rissinger. This is Glimoscope. It represents the Milky Way galaxy as we see it from planet Earth, but in different frequencies. Visible light, X-ray light, the gamma rays, the infrared light, the microwave observations, and radio light, which basically represents the main focus for this particular website and for the scientists studying all of this. With I think the best visual example of all of this being right here. This is a nearby galaxy known as Sgr A, and this is what it looks like in radio light. But it becomes barely visible in any other light, especially infrared, and even in the visible light you're barely going to see it at all. Although because it does have an active nucleus, or an active black hole in the middle, it is kind of visible in some of the higher frequencies such as gamma rays, but most visible in radio light. Anyway, that's kind of beside the point. The point here is that the galaxy or the entire night skies appear to us entirely different depending on what frequencies of light you use to observe it. So what we see with our eyes is entirely incomplete. But now, for the first time ever, the scientists were able to create the first map that's produced out of neutrinos. And although it's not as advanced as some of the other maps, it's already quite impressive. In this case, based on approximately 60,000 different detections over a period of about 10 years. Which in the process also discovers something very strange and somewhat unexplained about the Milky Way galaxy. Something we're going to discuss in a few minutes. First though, let me just clarify exactly what these neutrinos are and how we are detecting them here on planet Earth, because by itself it's already super impressive. Now the website for all of this is of course in the description below, but in a nutshell it uses what's known as IceCube Neutrino Detector, a facility located in Antarctica that was designed and built with only a single purpose. It uses these optical modules to try to detect neutrinos as they pass through planet Earth. But it does so by suspending thousands of these optical sensors deep into the ice of Antarctica, where there isn't really much it can interact with, except for particles that can actually go through all of this ice. As you can see, the depth here is almost 3 kilometers, and there are over 5,000 different sensors, all connected into one single network. And in terms of the sheer scale, this is pretty much as crazy as it gets. You have a remote facility located in the middle of Antarctica, where thousands of different tiny detectors are trying to discover these invisible particles that barely interact with any matter and usually pass through everything without any effect. But sometimes a neutrino passes through the location, emitting what's known as Cherenkov radiation. This is only produced when the neutrino interacts with one of the atoms inside. And this creates a kind of a three-dimensional shape that can then be used to track where the neutrino came from. Which by itself is already an enormous task, but it's been done several times now. And so after a couple of decades of research, various research teams behind all of these studies started to discover really powerful events coming from distant objects somewhere out there in the rest of the universe. Now intriguingly, some of the first ones discovered were actually some of the most unusual ones as well. That's because they were so extremely powerful. And they were coming from some really distant objects out there. And actually not just distant, but also extremely powerful. Some of the first cases were from well-known blazars. very powerful massive black holes whose jets are pointed directly at us. And so back in 2012, the IceCube made some of its first official discoveries. 2 neutrinos with energy approximately 100 million times more powerful than anything from a typical supernova. Although at first it wasn't really clear where this was coming from. But over time, more and more neutrinos were detected, and many seem to come from similar directions, from similar locations around us, although the source of many is still unknown. The typical explanation involves either supermassive black holes, powerful galactic collisions, exceptionally powerful gamma ray bursts, possibly even gamma ray bursts involving neutron stars, or some other very powerful supernova. And so, in a nutshell, the actual source of these neutrinos is still not clear, but they do often involve very powerful events. Although several locations have already been definitely confirmed. For example, we know that this blazar seems to produce very powerful neutrinos. It's located about 5.7 billion light years away from us. But the more interesting discovery was very recent, and it's actually from a galaxy known as Messier 77, the one that does resemble the Milky Way, and the one that was a source of neutrinos just a few months ago at the end of 2022. In this case, we're talking about very powerful neutrinos that seem to be coming directly from the center, from the active galactic nucleus. And quite a few neutrinos have also been discovered during a tidal disruption event that was detected in 2021 and then again in 2022. Confirming that a lot of these powerful neutrinos, in most cases, seem to actually come from central black holes. But going back to those maps I showed you previously, the ones visible in various frequencies, in order to understand the universe even better, it's obviously important to create maps in other frequencies as well. And for many years, a lot of teams were trying to figure out if we can maybe use things like cosmic rays, the radiation that comes from every direction striking planet Earth, and the radiation that's easily visible here on the planet. But the main problem with using cosmic rays involves their source or their origin. They're normally produced by charged particles, and when it comes to charged particles, they're obviously influenced by things like magnetic fields or other electromagnetic effects from the rest of the galaxy. And so in reality, even though they might appear like they came from a certain direction, their actual path might be very different, and they might have come from entirely different direction altogether. And so trying to figure out where these powerful cosmic rays came from would be very challenging unless we had some other technique or unless we used some other particles. But I guess more importantly, none of this would be good to create any kind of a map. But in many cases, the same things that release cosmic rays also release various powerful neutrinos. And in some cases, as these cosmic rays collide with things in outer space, they also release highly energetic electron neutrinos, which then move through the universe pretty much entirely in a straight line, almost at the speed of light. And in some cases, they only become noticeable when they interact with something on planet Earth. And so it's really because they don't interact with stuff very often that they sort of are one of the better candidates to create various galactic maps. They come from very powerful events, they move in a straight line, and they only occasionally interact with things, making themselves noticeable. And so here, by waiting years and years, it becomes possible to collect just enough data to then make an actual map, a three-dimensional map of the most active regions across the universe where all of these events must have come from. And this is precisely what various teams just did, announcing their results in June of 2023, picking up various emissions of neutrinos coming from various regions, including the center of the Milky Way galaxy. But obviously none of this was easy, especially because neutrinos can sometimes also be produced by our own atmosphere. And so here the scientists behind these papers had to basically figure out what's coming from outer space and what's coming from a little bit closer to home. In the end, producing something like this with the overall statistical significance of 4.5 sigma. Not exactly 5 sigma that's usually needed for a very confident discovery, but still good enough for something that needs to be investigated more, making this a super important milestone for mapping the universe with neutrinos and not electromagnetic radiation. And one of the most important discoveries here so far is that everything around us seems to be pretty bright with neutrinos, but not our own galaxy. For some reason, most things in the Milky Way are very dim in comparison to some of the brighter objects out there. Or just to rephrase this, other galaxies such as Messier 77 or a lot of other different galaxies that were able to produce powerful neutrinos in the last 10 years are dramatically brighter and way more effective at producing neutrinos than pretty much anything inside our galaxy or inside the Milky Way. And this is after 12 years of observations and nearly 60,000 data points collected from various locations. And so the result is very surprising. A lot of other galaxies are very bright in neutrinos, some much brighter than others. But the Milky Way appears to be very diffuse and very dim. It's about 10 to sometimes 100 times dimmer in overall neutrino brightness compared to many other galaxies nearby. And this is a huge question. It's really uncertain why. I mean, okay, the actual answer is because there are just not enough high energy sources in the Milky Way galaxy, and overall our galaxy appears to be very mild, but it's just unclear why this is so. Why are so many other galaxies near us produce so much stuff and have so many energetic events and various areas filled with powerful radiation and of course produce super powerful neutrinos, but nothing as powerful exists in the Milky Way. At least nothing in modern times. 100 times dimmer than most galaxies investigated so far. Now obviously one potential answer could be once again in the center of the galaxy. Maybe all this is directly connected to the central black hole. And maybe it's actually now that we don't see any neutrinos because the Sagittarius A star black hole is extremely quiet. But it's possible that millions of years ago, when the jet was still active and the black hole was producing a lot of energy, the Milky Way galaxy could have been producing just as many neutrinos as a lot of other galaxies. So here the answer is that maybe we just find ourselves in extremely peaceful, quiet times, with the central black hole barely producing any energy and barely causing any disturbance to the rest of the galaxy. But we know that it was active millions of years ago, and maybe that's when it was also a lot more productive in terms of neutrinos. I think one of the most mysterious areas in the entire galaxy is really its center. The galactic center in the Milky Way, or I guess really any galaxy, is filled with unanswered questions. And not even because there's so much stuff here. It's really because of all of the gas that's blocking the view of everything that could be hiding here. But in the last decade or so, various new telescopes and a lot of new techniques allowed us to finally see through all of this and allowed us to finally start discovering what's actually here. And here, there's a lot of stuff. Way more activity than anyone could imagine. But more recently, we finally started getting first images by the James Webb from this mysterious hidden region. The James Webb finally began its most exciting study of the center of the galaxy, with this first image showing us the region known as Sagittarius C. And so, hello wonderful person, this is Anton. Let's discuss the central region once again, talk about what was discovered in these new images, and of course talk about what else we know about this and what some of these mysteries potentially are. But here let's actually start with a slightly zoomed out map first, just so that you understand what we're really looking at. Because when we say galactic center, we don't really mean this bright blob in the middle. This is just called a galactic bulge. But if you start going closer and closer to the center, at some point you'll start noticing that there's a very highly dense region right in the center. A region with a lot of stars, all packed within just a few light years. And this represents the rotational center or the barycenter of the Milky Way galaxy. This is where the black hole is located, but also a lot of other massive stars. And though it's kind of difficult to imagine this, but there are roughly around 10 million stars in this region that's only approximately 4 light years across. And today we know that many of them have been formed during unusual bursts of star activity in the center that seem to correspond either to some kind of a galactic collision or a sudden influx of gas from the outside that creates these very powerful waves of gas which form these dense regions that then become stars. You can actually learn more about this in one of the videos in the description. And this is something that happens quite a lot because many stars here are only a few million years old. But because this whole region is hidden by so much gas, it's practically impossible to study this. Nevertheless, a lot of things here are visible in radio light, and quite a lot of things are visible in the X-rays and the infrared. This image shows us the X-rays, by the way. And although this is about 26.5 thousand light years away from us, today the telescopes are good enough to even see extremely small objects orbiting around the center. And this is of course how the black hole in the center was eventually confirmed. But majority of the previous studies were usually done on Sagittarius A. That's the brightest region, the one that contains the black hole, and the one that contains these millions of stars. But naturally, as these images show us, there are other things and other regions here with potentially other mysteries. And though we've discussed quite a lot of them, some of them even today have not been investigated very thoroughly. Nevertheless, even in this image, you can see lots of different stuff, and obviously lots of mysteries. For example, one thing that becomes really apparent is how many different supernova remnants seem to be here. Although in this case this is a bit zoomed out, with the distance across right here representing approximately 1000 light years. But even these supernova remnants seem to be really large. Like this one right here is approximately 240 light years across, and some of them happened only a few thousand years ago. And so at least a few of these supernova remnants that were studied previously were discovered to be just way too powerful, possibly 100 times more powerful than a typical supernova. At the moment there is no answer to any of this, but one of the assumptions was that maybe as the star passed very close to the black hole, it became compressed and due to this compression exploded extremely violently. With the other really unusual feature being these very strange threads. We've talked more about these threads in one of the videos in the description because thousands of them were discovered in the entire galaxy, but this is clearly the signs of magnetic activity right in the center. Then there are some other mysteries from Sagittarius B that surprisingly seems to contain very unusual emissions indicating that the black hole erupted 350 years ago. It's actually because the distance to this region is approximately 350 light years, and we're now detecting very strange emissions coming from Sagittarius B that seem to be coming from the central black hole. With the assumption being that approximately 350 years ago, our central black hole potentially exploded, producing 1,000,000 times more emissions than it currently does today. It's unknown why this happened, but it's obviously expected from central black holes. And we know that this happened many times previously, especially because of the observations from the famous Fermi bubbles. Now this very likely happened millions of years ago, but it was probably a lot more powerful. And even though in the last few years, so many of these regions have been explored by various studies, there was one region that wasn't. We surprisingly know very little about Sagittarius C, the least explored region located 300 light years away from the central black hole and estimated to have about 500,000 stars forming there right now. And it's actually the radiation from these stars that produce these beautiful nebular structures. But the mystery here is, why exactly are they forming there and how are they able to form in such a dense region? And not just a dense region, an extremely intense region with so much radiation and so much activity from the central black hole. And so now we have this new image from the James Webb showing us a cross-section of approximately 50 light years, discovering some of the main features here, but also discovering certain mysteries. For example, for the first time ever, the researchers discovered this enormous protostar cluster, with at least one star here being 30 solar masses in mass. And there's so much activity going on here that this entire cloud basically becomes ionized hydrogen, or in other words, it becomes a very bright nebula. There's also this unusual dark cloud resembling a kind of a hole. But this is not a hole, this is actually where a lot of future stars are forming. They just haven't become stars yet, and instead have a lot of gas that's blocking everything here. We sometimes refer to these similar structures as dark nebula or absorption nebula. Quite a lot of these exist around the Milky Way, produced by tiny interstellar dust grains, with these tiny dust particles potentially containing carbon monoxide and nitrogen, and very likely a lot of other organic compounds, blocking the passage of light. And so at some point, this will probably also become very similar to this feature, but it first has to start forming stars that can then illuminate all of this gas. And then once again, we have a discovery of these unusual needle-like structures of ionized hydrogen, which in this case, unlike in the previous image, where they mostly seem to point perpendicular to the galactic disk, very likely representing some kind of a magnetic line, in this case, these unusual needles seem to be more chaotic and pointed everywhere. Now their origin is most likely magnetic in nature as well, but in this case it basically suggests magnetic fields here are extremely chaotic and seem to point in every direction. In other words, this shows us a very turbulent region with a lot of magnetized gas clouds that seem to be forming stars and as a result affect everything around them with very powerful winds, jets, and lots of radiation. Or at least that's what we know now. This is a brand new image, and so there are no actual studies yet or any specific discoveries in regards to what we're looking at here. Nevertheless, it's exciting to hear that James Webb is finally looking at the center of the galaxy, which means that in the next year or maybe 2 years, we're going to have so much to talk about with so many new discoveries and potentially new objects that we never knew existed. This is by far one of the most beautiful images of this entire region and definitely shows us the power of this beautiful telescope. Well, it's time for a new James Webb Space Telescope update. And in this case, I actually wanted to focus on some of the major discoveries coming from the Milky Way galaxy, but specifically in regards to various nebula and the idea of star evolution, from the birth of stars all the way to their end. And that's because in the last few months, James Webb Space Telescope was able to capture some absolutely breathtaking images of quite a lot of well-known, gorgeous nebula. And though obviously we've discussed quite a lot of previous discoveries and talked about some of these images before, in this video I wanted to focus on some of the major discoveries in regards to the science behind these images and what exactly these images have taught us so far on how stars evolve in the Milky Way galaxy. So, hello wonderful person, this is Anton, and let's discuss various JWST nebula captured in the last few months. And let's start with one of the closest images to us, but also maybe one of the most breathtaking when it comes to the actual scale. This was released very recently, and it's essentially a close-up of a very well-known molecular cloud, Rho Ophiuchi, a gorgeous molecular complex containing approximately 50 young stars, with all of them surprisingly very similar in mass to the Sun, which in some sense basically shows us what probably happened approximately 4.6 billion years ago when the Sun was formed as well. It very likely started with a very similar molecular cloud. And at 390 light years away from us, this is the closest such object. But what exactly are we looking at? Well, I think the biggest structure here are these bipolar jets of molecular hydrogen, visible in red, that in essence are being expelled by various young stars in the middle. Now we'll actually discuss this in a few seconds, but in essence, once stars start forming in a lot of these complexes, they will often produce these very unusual, long tendril-like formations because of what happens right around the center of the star. We obviously think our Sun must have gone through this as well. Although some of these stars that you can kind of see in front have already sort of developed themselves, with many of them expelling most of the dust and very likely already developed into fully functional planetary systems. And so to some extent, this image shows us the beginning of everything for most stars. So pretty much every star around us began in one of these clouds. But if you were to zoom in on one of these stars, or essentially try to zoom in on one of these very long tendrils, you would most likely be looking at something like this. Now this is the second image I wanted to show you of an object known as HH211. HH stands for Herbig-Haro, and in essence all Herbig-Haro objects have a very similar structure. This is probably the most famous one, the one we've discussed in one of the videos in the description. All of them are very young stars, possibly only a few thousand years old and still growing and developing. But just like your typical black hole or neutron star, because these are fast-spinning magnetic objects that also possess an accretion disk, they eventually develop these polar jets that travel through interstellar space at very high velocities. Now, if this was a black hole, the velocities would be very close to the speed of light. But because this is a baby star, here the velocities are much more modest. In this case, it's maybe about 80 to 100 kilometers per second. And based on the observations from similar Herbig-Haro objects, it became possible to analyze exactly what happens much closer to the center where this huge outflow occurs. And that's despite the distances, in this case it's about 1000 light years away from us. And so here we seem to have an object that's about 8% the mass of the Sun, but it seems to be growing very rapidly. And that's actually because the accretion disk and the polar jets form a sort of a fountain around the star where quite a lot of material gets deposited into the star, but also quite a lot of it gets expelled in these jets. In some way you could maybe imagine it like this: a huge funnel powered by the magnetic field and the gravity from the star. But for this object, the outflow very close to the star is a little bit slower, which suggests that the materials coming out of there seem to be a little bit heavier. In this case, it's probably molecules and not just atoms. And so here, it's not just hydrogen, which probably moves much faster, but also much smaller, potentially organic molecules, including things like carbon monoxide. So in essence, there's a kind of a multi-level flow coming from the center of the star. There's obviously a flow of hydrogen, but there's also a flow that moves slower that seems to include much heavier molecules, which by itself shows us the next step in star evolution. Following the formation inside the molecular cloud, a lot of stars experienced this for thousands and thousands of years, eventually evolving and developing into final objects, main sequence stars. Although in this particular case, scientists have also detected some kind of a wiggle, which implies that this is probably a binary system. Another object seems to be pulling on something in the center, creating an outflow that's not entirely straight. So we're basically observing a formation of a binary system. Although intriguingly, when it comes to star formation, a lot of these observations from various nearby molecular clouds show us something a little bit different from what happens closer to the center of the galaxy. And in the center of the Milky Way, there is a region known as CMZ, Central Molecular Zone, a region containing giant molecular clouds that seems to be 2000 light-years across and contains 60 million solar masses of material. And right there in the middle, there's an unusual region known as the brick, something that looks like this if zoomed in. And so the recent observations by the James Webb were able to analyze this massive cloud gas that's sometimes referred to as the infrared dark cloud, showing us what's happening here as well. And generally speaking, these types of molecular clouds or these types of regions are extremely different from what we have much closer to the solar system. They're way more denser, containing a lot more stars, and potentially also a lot more star formation. Although the brick seems to be a little bit different. It shows less star formation compared to regions nearby, but seems to be just as dense and seems to contain just as much turbulence. But because this is such a dark region and because a lot of dust blocks a lot of light, it's always been a very difficult region to study. Nevertheless, despite being somewhat dark and appearing somewhat inactive, it seems to contain at least 56,000 stars that are being formed there right now. And surprisingly, this is actually on the lower end for this unusual central region. Many other locations here have way more stars being formed much faster. But previously all of this was kind of invisible. Now it is visible because of carbon monoxide, the gas that's very bright in certain infrared frequencies. And turns out that this brick region contains huge amounts of carbon monoxide that seems to act as a kind of a coolant. And since star formation usually happens in much cooler regions, especially in dense regions of similar gases, technically we expect a lot of stars to form here, because finding so much carbon monoxide generally indicates higher rate of star formation. But that's not what's observed here, because for some reason the gas here is a little bit warmer. And at the moment that's a mystery nobody can explain. So basically all of the gas present here should be forming stars, but it's not doing that, because something in the central region is warming everything up. Nevertheless, the discovery of so much carbon monoxide is definitely kind of exciting. The ratio of carbon monoxide to hydrogen is much higher than anywhere else in the galaxy. And so trying to understand exactly what happens in these regions and how the star formation here might be a little bit different is going to be one of the future goals for the James Webb staring at the center of the galaxy. Right now this is really more of a mystery that nobody still understands. And then we of course had some really exciting observations from the famous Orion Nebula. Specifically the Orion molecular cloud, where even more stars are forming, with many once again very similar to our Sun. And here the scientists discovered something that was really surprising. It's known as methanium, sometimes referred to as methyl cation. Basically a carbon compound that seems to be extremely important for organic chemistry happening in the interstellar space. And though it's not something that naturally exists on planet Earth, it seems to be absolutely crucial for theoretical explanation involving various complex organic molecules detected in outer space, including various amino acids or building blocks of life that were discovered by various telescopes in the last few years. The only way to explain their existence or how they could form is through various complex processes that must happen in outer space in various molecular clouds, which by the way is directly connected to the potential existence of life on other planets or even to evolution of life on planet Earth. Huge amounts of these compounds most likely came from outer space. And so by conducting observations in the Orion Nebula, a team of scientists discovered methanium hiding in plain sight, located in quite a lot of regions of the Orion Nebula, suggesting that it's basically performing a lot of chemical reactions right now. with the main focus being this unusual star named D203-506, some sort of a small red dwarf that's obviously still growing, and that's also receiving a huge amount of UV radiation from many nearby stars. These types of environments are very common in many molecular clouds, but these very massive stars producing UV light only exist for a few million years. They go supernova afterwards. And though these very powerful types of radiation are supposed to destroy a lot of different complex molecules, it does not seem to be the case here. Because it turns out UV radiation promotes the formation of methanium. And so once those stars disappear, in theory there's a huge amount of methanium floating around various stars and in the interstellar space, which is precisely what's been detected here as well. And what's really strange about this unusual molecule is that it doesn't react with hydrogen, but it loves reacting with a lot of organic compounds. And so it acts as a kind of a stepping stone for the formation of more complex molecules that then produce things like amino acids. Although in this case also showing us that UV radiation in general seems to be critical for the formation of complex chemistry in various molecular clouds. In essence, explaining how a lot of complex stuff must have formed in the solar system as well. So yeah, some really cool discoveries. But so far we've just talked about formation of stars. Now obviously James Webb has looked at various developing stars, but it also looked at stars very close to the end of their life, or even stars that have already transitioned into something else. And so here let's take a look at some of them. For example, there was the image of what's known as a Wolf-Rayet star, in this case WR124, that represents a massive star that's most likely going to go supernova in the near future. And here, as these stars evolve, they form these huge shells around themselves, even visible from a distance of 15,000 light years. Now this particular star is about 30 times the mass of the Sun, but it already released approximately 10 solar masses into outer space. That's what you actually see around it. And here the main point is trying to figure out how these various stars contribute to overall dust in the entire galaxy. All of this dust will eventually get recycled, forming new stars, and so trying to see what kind of a dust is being released is obviously kind of intriguing. Although in this case one of the main discoveries is just the observation of various very clumpy regions that seem to form as they're expelled from the star. It's not entirely clear where all of this goes just yet. But eventually the star is going to go supernova, and is going to produce something similar to this. This is the other observation from the youngest supernova in the Milky Way. It's known as Sgr A. This most likely happened about 340 years ago, but it looks like nobody on Earth might have actually seen it. We've talked about this a little bit more in one of the videos in the description, but one of the reasons is probably because it's kind of far away. 11,000 light years away from planet Earth. And so once these massive stars explode, they once again produce another beautiful dust cloud, obviously different from the ones we saw previously. And here it seems to once again produce these various clusters, or various mini bubbles, with a lot of really complex shapes, and more importantly, unlike previous clouds that usually contain light elements, here we have a lot of heavy elements, oxygen, argon, neon, and of course a lot of metals like calcium and iron. But here there are also unusual structures that are still kind of mysterious. For example, these unusual green protrusions that scientists are referring to as the green monster. It's not clear what exactly produced this, but they seem to be all over the place. And so in essence, by observing these supernova remnants, we're looking at the end of star formation as the stars evolve and as they finally release all of the heavier elements that they managed to create over millions of years. But in this case, this was very likely a much more massive star. What about stars like our Sun? Most stars out there are much less massive, and so they actually produce something a little bit different. And here we're talking about what's known as planetary nebula. This is the famous Ring Nebula, recently observed by the James Webb. Here this is an expanding shell of gas coming from the star in the middle that occurs when the main sequence star, like our Sun, first becomes a red giant, then becomes a white dwarf. Now this object is about 2600 light years away from us, but it's one of the most well-known planetary nebula and one of the most studied objects. Here the star in the middle is a white dwarf, approximately 0.58 solar masses in mass. It's also surprisingly really bright and very hot, 135,000 Kelvin, 310 solar luminosities. But this is something we've known before. But the James Webb was able to discover something else. For example, approximately 20,000 unusual dense clumps that you see right there that actually seem to contain almost half of the total mass released from the star. And quite a lot of the material here represents very complex organic molecules, such as for example the very important polycyclic aromatic hydrocarbons, a very important precursor that's responsible for forming everything inside our bodies. But the more detailed examination discovered at least 10 different arcs, suggesting 10 powerful emissions when the star was in its red giant stage. There are also approximately 400 different spikes that seem to have formed as a result of some kind of a turbulence. And surprisingly, there are also quite a lot of carbon-based molecules whose origin is currently unknown. Although some of these formations and some of this turbulence is most likely because this is technically a triple system. The central star has at least 2 companions, and the farthest one seems to be a red dwarf as well. But in this case, we basically get to see the other side of star evolution. The end of life for most stars out there, the ones that cannot go supernova. And in this case, they also recycle their gas, but different gas in somewhat different ways. Unlike a supernova that produces a lot of heavy elements, here we get a lot of organic molecules and a lot of lighter elements that then become interstellar gas. So super exciting stuff, and just like after 1 year of operations. So you can only imagine what we're going to find out in the next 10 years or so. I'm super excited about these future results, and I'm sure we're going to learn so much more about star evolution in the next few years. But there were of course so many other images captured by this iconic telescope. We've discussed many in some of the previous videos, and we'll definitely talk about other ones in some of the future videos as well. But before we finish this video, I wanted to mention a couple that were not in the Milky Way, but also showed us something really important. One of the most important observations was actually a combination of James Webb and the Sophia telescope that's now officially retired. This was the observation from the iconic Tarantula Nebula, and specifically the cloud known as R136. This is where we find huge amounts of massive stars, and basically the most massive stars discovered in the entire universe. Now here, this is what the new image looks like. It shows us the magnetic fields and the interplay between magnetism and the gravity. And because these are very complex magnetic fields, they seem to produce very surprising results. They basically seem to prevent certain gases from forming stars in certain regions. Now first of all, this nebula is forming stars ridiculously fast. It actually kind of mimics what happened in the universe approximately 11 billion years ago. But if you look at this image, you'll see that in some regions there are no stars, which was a bit of a mystery at first. Turns out that a lot of these regions seem to also have powerful magnetic fields. These regions resist turbulence and prevent gravitational collapse. And so only in the regions where the field is much weaker, the gas is able to escape and eventually form stars. But here, the power of the magnetic fields definitely acts as a kind of a switch for star formation in the entire cloud, while also potentially holding everything together. Technically, the cloud should have fallen apart a long time ago. And intriguingly enough, most of these fields are produced by the stars themselves, or specifically by various activity very close to them, so in some sense it's a kind of a feedback mechanism. More star formation leads to more stars, leads to more magnetic fields, which then can actually shut down star formation in certain locations. So definitely some intriguing results, but still not super clear on how all of this works. And since we've talked about the Large Magellanic Cloud, here's also a picture from the Small Magellanic Cloud, another beautiful star-forming region containing thousands of stars. In this case, one of the most exciting discoveries here is the presence of thousands of different filaments in this region known as NGC 346. And as I mentioned in the beginning of the video, all of these filaments are very likely baby stars with very powerful jets. Basically gas that's being blown away from young stars, as many of them seem to form around the cloud. Although in this case, what's exciting about this cloud is that it seems to have a lot of material that's somewhat primitive, very similar to how it was billions of years ago, making this one of the most interesting star-forming regions visible from planet Earth. Hello wonderful person, this is Anton, and in this video we're going to be discussing some of the recent discoveries that seem to redefine our understanding of our own galaxy, the Milky Way. Discoveries usually using new simulations or new telescopes that recently helped us realize the Milky Way galaxy is maybe just a little bit different from what we originally thought. or possibly even very different, as you'll learn from some of the recent studies. And actually, in that sense, let's maybe start with one of the more extreme discoveries coming from some of the most recent and most accurate observations using the iconic Gaia telescope. ESA's telescope that's been actively mapping the night skies for the past few years. And because this telescope is extremely good at measuring the velocity of stars in the Milky Way galaxy, it actually allows us to see precisely how fast stars move around the galaxy, dependent on where they're located and how far away from the center they are. Which then, in essence, allows us to establish the overall shape of what's known as the galaxy rotation curve. The curve that shows us how fast stars move much farther away from the center, which usually allows the scientists to determine the overall mass of the galaxy. And despite predictions decades ago, where scientists believed that stars farther away should be moving much slower, which is known as the Keplerian motion, which is of course what's observed in a typical star system, unlike planets, stars do not follow the same rules. They actually usually possess a very similar velocity independent of a distance. And by knowing this velocity, we can then work out the mass of the galaxy. And so something similar has been assumed for many years for the Milky Way galaxy based on previous observations of certain stars, which allow the scientists to determine its mass as well. A lot of these recent calculations establish the mass to be approximately 1.2 to maybe 1.3 trillion solar masses, which is quite comparable to many other similar galaxies, including the Andromeda. But the recent observations and calculations from the European Space Agency and astronomers from the Paris Observatory used approximately 1.8 billion stars to recalculate the mass of the Milky Way, in the process discovering that the actual galactic curve does not seem to be as straight as initially assumed. There is actually quite a lot of Keplerian deceleration, suggesting the galaxy does not have as much mass. And this is actually really weird because for a large spiral galaxy, normally the galactic curve is completely flat. This one is definitely not. With this recent study re-establishing the mass at practically 5 to maybe even 7 times less massive. Instead of 1.2 trillion, it only seems to be about 207 billion solar masses. With this unusual Keplerian decline basically suggesting a major decrease of dark matter on the outskirts, and thus a major drop in mass for some very unknown reasons. Now by itself this is actually a pretty huge discovery and needs to be definitely confirmed, but so far the results look pretty strong. And so whatever is happening here is essentially a new mystery and also suggests that our galaxy is way less massive than we ever thought possible and is almost 10 times less massive than the Andromeda. So definitely something weird going on here, but that's not the only strange discovery recently. Another recent analysis using what's known as the Illustrious simulation, the most famous galactic simulation in existence, discovered that based on the parameters of our galaxy, and based on its location compared to other galaxies, specifically located inside a local sheet of galaxies on the outskirt of a galactic wall, for a galaxy like ours to exist, it would actually take a lot of chance. Basically, it makes our galaxy extremely special. First, they discovered that the spin of the galaxy seems to be relatively fast and also very well organized. Our galaxy was also a lot bigger in size, with most objects inside the galaxy generally possessing a relatively low velocity of dispersion. Basically, most objects inside the Milky Way do not move as fast as in some of the other galaxies. But because the galaxy was spinning relatively fast, and was also inside the location with a lot of other galaxies, many of these parameters were expected to be very different. And so in the simulation, they only actually found one such galaxy within several hundred million light years produced by the simulation. Although one thing to correct here is, if we do consider the results from the previous study, they also assume that the galaxy was much more massive. If it is less massive, then it actually does become a little bit more common. Either way, the results from the study suggest that, according to simulations, galaxies like the Milky Way should actually be just a little bit different. They should be maybe a little bit more hectic, potentially have a little bit less rotation speed, and obviously be less massive. So that the less massive part seems to work out for now. Other parts, not so much. Maybe it's a special galaxy after all. But a lot of these anomalous observations might also be explained by the overall shape of the galaxy. We are looking from the inside, so we actually do not see the entire shape, but because of Gaia we're able to work out the shape with time by observing individual stars. And most of the studies now more or less confirm that the galaxy, first of all, is not flat, and second of all, even has these unusual flares that you see right here, that basically make stars extend kind of like little feathers from the end of the disk. And so quite a lot of recent studies establish that this is actually very likely because of the unusual shape of the galactic halo where the galaxy is located. All galaxies contain a large halo of stars, gas, and the invisible dark matter extending up to several million light years away from the center of the galaxy. And for the Milky Way, the original assumption was that maybe it was something like this. You can actually see the partners Large and Small Magellanic Cloud inside this halo as well. But turns out that, well, things here just look a little bit too perfect. The halo is too spherical, the galaxy is way too flat. But the reality of the halo shape seems to be a little bit more different. It actually seems to be almost egg-shaped and seems to be skewed by about 20 degrees. And so because the dark matter halo is skewed so much, it seems to have shifted the shape of the galaxy as well. And so based on various simulations, the researchers established that maybe about 7 billion years ago, there was some kind of a galactic collision that very likely shifted the position and the shape of the halo. And as soon as that happened, the actual galactic shape started to shift dramatically as well. It very likely tilted the galaxy by about 25 degrees almost right away, within just a few million years. But because there is so much mass in here, it took about 5 billion years for the tilt to decrease from 25 degrees to 20 degrees as it is today, which then realigned the galaxy just a little bit, but not by much. And so in essence we have a galactic collision to blame for all of this. We don't really know what galaxy and when exactly this happened, but it's very likely the reason why the halo is so shifted, why all of this is still tilted even today, and why the Milky Way appears to be so warped and possesses so much chaotic activity, especially at the edges of the galaxy. Which is of course a pretty good explanation, and might even provide explanations for some of the previously mentioned mysteries, but at the moment it's obviously unclear if any of this is connected just yet. These are, at least for now, separate observations. And one of the last exciting discoveries coming from the Gaia telescope involves the chemical analysis of various structures in the Milky Way, at least relatively close to us. Basically here we're talking about the new concept known as chemical cartography. And well, this is what it sort of looks like. The sun is somewhere right there, and you get to see red and blue spots indicating either high or low metallicity. Or essentially red would be things like carbon, nitrogen and oxygen, or even more complex elements, whereas blue is mostly hydrogen and helium. Here's what the actual map looks like as seen by the Gaia telescope. All of this was then converted into 2 dimensions. And so what this reveals is that there are definitely very thick patches of young stars, or I guess high metallicity stars, in certain locations in the galaxy. And it just so happens that these locations seem to match with features we refer to as galactic arms. In other words, kind of confirming that, as researchers always suspected, a lot of young stars seem to be produced inside galactic arms, and a lot of ancient stars seem to be mostly located in between galactic arms, with a lot of spiral arms overall being a lot more enriched in a lot of metallic or heavier elements. Here you expect more supernova, more star formation, and generally just a lot more activity. And though by itself this is not a groundbreaking discovery, it basically confirms a lot of assumptions many astronomers already had. What is exciting is just this new idea of chemical cartography. The ability to actually trace the entire galaxy, not just in the location of stars, but also in where exactly different elements are as well. Which by itself opens new doorways for a lot of new science. And so yeah, quite a lot of exciting discoveries, a lot of super exciting and unusual explanations, and at least a couple of new facts we currently cannot explain. Like for example, what exactly happened to the mass of the galaxy? Why exactly does it appear to be so much less massive than we ever thought? And if this is actually confirmed, currently there is no explanation for what's going on. Hello InfoPerson, this is Anton, and today we're going to be discussing some of the new discoveries coming from right here, the Milky Way galaxy. And I guess more specifically, from the center of the Milky Way that you see right here, with this beautiful composite image created by NASA, showing us the incredible beauty of this very unusual region. Although this image, taken with the radio frequencies, definitely shows us how extremely active this region is, and how so much unusual stuff is going on there, pretty much at all times. But as you probably know, it's also the region containing the central black hole, Sagittarius A star, whose picture was reviewed not so long ago. And it's also the region containing quite a lot of very unusual objects, some of which were only discovered in the last few years. For example, these unusual features that we still don't really understand very well, referred to as the G objects. They sort of act and look like stars from a distance, but as they approach the Sagittarius A star black hole, they tend to sort of fall apart, stretch just a little bit, and turn into these unusual very powerful clouds that potentially lose some mass and become star-like objects as they orbit farther away from the black hole. And all of this was only learned in the last few years. These objects are still quite mysterious. But over the last decade, as the scientists observed this region more and more, they started to discover other unusual stars as well. Like, for example, the ones you see orbiting are known as S-stars, and they seem to be permanent residents of this unusual region. Their true origin is still unknown to us, but generally the scientists believe that they might have been captured from farther away and might have been created somewhere within the central region, possibly a few millions or even billions of years ago. As a matter of fact, one of the fastest moving stars in the galaxy is located here as well, and it's one of the S stars that moves at over 10,000 km per second at its closest approach. But various observations started revealing something else, something that could not be explained at first. The scientists have also started finding some relatively young stars. Stars only a few million years old, suggesting that if they were actually created somewhere, they might have been created extremely close to the central black hole. Or somewhere within this very active region that does have quite a lot of activity. But star formation has never really been seen here. As a matter of fact, because of all of this super highly energetic activity, and because of the high amount of X-rays, UV radiation, and a lot of other very dynamic processes, which does become quite apparent when seeing all of this in radio light, explaining their origins so close to the black hole has always been very challenging. These extremely active conditions and huge amounts of radiation should not really allow any star to form. Generally, star formation in various molecular clouds requires a bit more stability and much milder radiation levels as well. So these conditions should prevent formation of stars like, for example, our Sun. But quite a few of these young stars have been found here and did present a bit of a mystery. A mystery that, up until recently, or actually up until now, could not be solved. But now the scientists have officially solved it. They have finally discovered the first ever baby star that's being physically formed right now extremely close to the central black hole and seems to be only a few thousand years old, making this one of the youngest stars discovered in general. And because of this is not technically even a star just yet. It's known as YSO, or YSO, I guess? Young Stellar Object. Quite a few of these have been discovered over the past few years in various molecular clouds, and they do generally have very similar features. Extremely bright in the infrared, very active, but still not true stars because normally they don't really have nuclear reaction just yet. A lot of these newborn stars usually are surrounded by a lot of gas, and even produce these gorgeous jets, visible from really far away, that tend to actually decrease their overall mass over time, but sometimes are also responsible for the formation of planets, as some of this gas then returns back into the protoplanetary disk. And generally their features and their properties are pretty well understood based on a lot of observations very close to us. Which is why the scientists were so excited to discover extremely similar features appearing at a distance of about 26,000 light years away from us, very close to Sagittarius A star. Implying, of course, that maybe, just maybe, this is some kind of a baby star that seems to be producing these unusual formations, and as it interacts with the gas around it, it leaves behind a wake that's visible from a very far away distance. With the simulations definitely agreeing with the observations, and at the moment presenting the best possible explanation. Although obviously because of the distances and also because we don't really see the details, for all we know it could still be some kind of a different mysterious object. But it's a lot more likely that this is indeed a young star being formed here, which will potentially help the scientists finally solve the paradox of youth, as it's sometimes referred to. The paradox of detecting so many young stars extremely close to Sagittarius A star. With all of the observations right now suggesting that this is an object approximately 10 times bigger in terms of size compared to our Sun, and about 15 times as massive. And because it represents a young massive star, it's going to evolve really quickly, possibly only taking a few tens of thousands of years. Although obviously its ultimate fate is currently unknown. It's probably going to approach the Sagittarius A star and might fall apart, losing some of its mass, or it might survive for millions of years and eventually explode as type 2 supernova, producing more dust and producing more clouds. Or it might also turn into one of these G objects, potentially explaining their origins. But more importantly, it definitively confirms that there seems to be a region extremely close to the black hole, possibly a few light years away from the center, that seems to contain conditions perfect for star formation, being cold enough and protected enough from various types of radiation, with just the right density where a sudden cloud formation can turn into a star. But more importantly, can actually create even more larger clouds, possibly hundreds of solar masses big. And interestingly, some of these clumps seem to already exist in the vicinity of the star and could potentially even be absorbed by it, making the star even bigger with time. Which is probably how it was able to reach such a huge mass already. It might have started as a much smaller star, but absorbed more and more dust over the last few thousands of years. And because this is such an energetic and dynamic region, all of this happens really fast. And so many of these clouds have already been discovered in the last few years. Here's actually a recent one found only a few weeks ago, known as X7. You can see that it's already sort of stretched and seems to be approaching the central black hole. And as seen so many other times, this unusual cloud is becoming more elongated and is already approximately 3000 astronomical units long. But because it's currently approaching the central black hole, with time it's obviously going to become even longer and might potentially lose some of its mass to the black hole itself, which could possibly produce what the scientists refer to as the fireworks. Its total mass is believed to be approximately 50 Earth masses, and it seems to be orbiting around the black hole with an orbital period of about 170 years. And it's probably going to make its closest approach around the year 2036. But what happens afterwards is not entirely certain. It might completely fall apart and just become diffuse gas, or could reconnect again, thus explaining the origin of mysterious G objects. Maybe this is just another G object that's slightly on a smaller side. In this case, if it does reconnect into a single object, it might only be planetary in size, but surrounded by a very large dust cloud. But because it's already moving really fast, approximately 700 km per second, at the moment it just looks like extremely long cloud of gas. But in this case, much closer to Sagittarius A star than the newly discovered X3 star. So there's definitely a region around the black hole where things are much calmer and where it does seem to be possible for various objects to coalesce into stars, planets, or possibly something else. And so it's quite possible that the region approximately a few light years away from the central black hole serves as a kind of a Goldilocks zone for the formation of various star-like objects, especially the young ones that have been discovered in the last few years. But one of the best ways to try to prove this is of course to try to find these in other galaxies. If the scientists can find something similar in a galaxy nearby, this would be a telltale sign that this is exactly what's happening and that it seems to happen pretty much everywhere across the universe. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries coming from the outskirts of the Milky Way galaxy, and specifically somewhere between the Andromeda, which you see right here, and the Milky Way. And that's because relatively recently, some of the scientists using some of the modern techniques were able to discover these really exciting stars known as RR Lyrae stars, pretty much right between the Milky Way and the Andromeda. And even though technically they could be considered to be intergalactic stars, in reality, they're actually part of the Milky Way, representing a part of what's known as the outer halo. In other words, they've discovered some of the most distant stars from our own galaxy at some ridiculously faraway distances, once again confirming that the Milky Way galaxy is a lot larger than we originally thought. And so let's discuss all of this in a little bit more detail, starting of course with the idea of the Milky Way and its structure. Now, to some extent this shows us what's happening here. We obviously have the galactic disk, the inner halo and the outer halo, but in reality the image of the Milky Way, as you might have learned from some of the previous videos, is way more complicated. In the last few years the scientists have discovered that not only is our galaxy warped and stretched, it also contains a lot of shifted and twisted structures around it, it contains a lot of different streams, and it also contains a lot of material and a lot of gas, and of course stars and globular clusters, at the outskirts of the galaxy, orbiting thousands of light years away. Moreover, it was discovered that the actual size of the galaxy, if you include things like the outer halo, is approximately 1 million light years across. And since the Andromeda galaxy is also around the same size, it means that technically the galaxies are already touching and are already colliding. This was only discovered a few years ago. But because this is science, you always want to have more proof of even the most common theory. And so here the scientists were really trying to figure out if the outer halo really reaches that far. And there's really only one way to do this. Look around and try to discover as many possible stars around the galaxy, indicating that they really are there, and they really are as far away as we originally assumed. But that's of course the most difficult part. Measuring any distance in space is usually very challenging, and normally to find distances to relatively close objects, the scientists tend to use stars that exhibit various patterns, for example they kind of blink. And the most popular type of a blinking star to measure distances is known as the Cepheid variable. These are stars that generally do something like this. They increase and decrease in brightness quite regularly with a very predictable period. Here's one example from M31. And in this case this usually depends on the mass of the star and usually produces a very specific type of brightness. And so by knowing the period of the variable, it becomes possible to determine its maximum brightness, which can then be used to create what's known as the cosmic ladder, also known as the standard candle ladder, which in essence depends on understanding how bright certain objects are, and by knowing their brightness, it's possible to then determine distance to those objects. This is literally how we know the distances to pretty much everything around us within about a few million light years. At farther distances there are other things like redshift. And this is especially true of various globular clusters. They tend to contain at least some variables inside of them, which allows the scientists to determine very precise distances. And one such variable is also known as the RR Lyra, named after the first such star. And these are actually really exciting stars that can potentially determine super exact distances for one simple reason. They all produce almost exactly the same variability. Actually, they almost look like a heartbeat. The brightness goes up really quickly and then comes down really slowly with an extremely predictable cycle and a very specific shape. And their average brightness is usually relatively same, independent of everything else. Moreover, they're usually around half of the Sun's mass and generally contain the same spectral class, either A or F, implying that they were all made from very similar stars, approximately 0.8 solar masses. But more importantly, unlike other Cepheid variables, which are normally found around the galactic disk, the RR Lyra stars tend to be everywhere, independent of the galactic structure, and can even be found extremely far away from the galaxy itself. And that's because of their mass. Their mass allows them to survive for billions and billions of years. And they actually remain the same with the same properties and the same pulsations for this entire time. And so in a typical galaxy, because of various galactic collisions and galactic interaction, with time all of these RR Lyra stars can find themselves in any part of the galaxy, even super far away. And because of their age, they're also extremely populous. They're probably the most common types of Cepheid variables. Several thousand are already known, and it's estimated that there are maybe about 85,000 in the entire galaxy, which of course allows the scientists to then measure distances, especially if we find these stars, inside various objects such as globular clusters. But in this case, that's not what the scientists wanted to find, because they really just wanted to find some of the farthest ones in order to identify the potential limits for the outer halo. But because these stars are not as bright as some of the other stars, at certain distances it becomes kind of difficult to see them. These are not giant stars, they're actually even smaller than our Sun, and so trying to find them at even thousands of light years away becomes a bit problematic. But there are obviously missions that have been trying to map stars for a very long time now. For example, the Gaia telescope has mapped about 140,000 Lyra stars already, with many of them still not analyzed by anyone. But in this recent study, the scientists managed to find some of the farthest ones using a slightly different and more clever technique. In this case, the scientists realized that previous surveys of various faraway clusters, such as the Virgo cluster that you see right here, would often try to erase or get rid of various foreground stars in the same field of view because they were mostly interested in distant objects such as galaxies. You can kind of see that there are a lot of missing stars in this image. But this unusual byproduct is exactly what the scientists behind this study wanted to actually analyze. Turns out that some of these stars were RR Lyra stars, and some of them were really far away from the Milky Way, which allowed them to find 208 stars, anywhere from about 60 light years away all the way to 1 million light years away from planet Earth. And all of them pretty much located in the halo of the Milky Way galaxy, confirming that the outer halo definitely extends to a distance of about 1 million light years at least. And although in this case, the scientists also believe that it's mostly made out of dark matter, It also definitely contains quite a lot of gas and a lot of stars, and extends to much farther distances than we believed. And so once again, the Andromeda and the Milky Way are very likely already touching. Or basically the collision between galaxies has technically already begun. Or maybe to some extent. The gas is already probably interacting, and some of the outskirt stars might already be passing very close to one another. Although as I mentioned previously, it's quite unlikely that any of the stars will ever collide. But I guess what's important here is that using this same technique, it's now going to be possible to discover even other stars, possibly even farther away, and potentially even map the entire structure of the outer halo if the scientists can use other surveys to discover even more stars. Although I guess one thing that makes these particular stars kind of interesting, intriguing and mysterious is just the fact that they all seem to be mostly individual stars. They don't seem to come in pairs or in binaries, and so even their origin story is a bit mysterious. Hello wonderful person, this is Anton, and today we're going to be discussing some other really exciting discoveries coming from the Milky Way galaxy, and actually discoveries that once again nobody kind of expected. Discoveries that you can learn more about in one of the papers in the description below. But also a discovery that's, in some sense, almost like 45 years in the making, because the scientist behind this main paper has been studying these particular phenomena since the early 1980s. And it's essentially directly related to that discovery from the 80s of these unusual floating filaments discovered around the galactic center. If you want to take a trip back in time, here's that original paper by the same scientist published 39 years ago. And so back then, he discovered these unusual filamental formations that were basically only visible in radio light. And quick reminder, if you actually want to ever see what the galaxy looks like in the radio light, check out the map in the description that allows you to see everything in the X-rays, in the gamma rays, in the infrared light, microwave light, and lastly, radio light. And so when looking at the Milky Way in the radio light, something exceptional comes into view pretty quickly. Our galaxy contains a lot of these very beautiful filamental features, very often up to 150 light years in length, vertical in orientation, and most likely following the magnetic lines of the galaxy itself. And the scientists behind this paper discovered over 1,000 of these in the last 4 decades. As a matter of fact, we've discussed many of these discoveries in the past because they do show our galaxy in a very different light, and serve as evidence for magnetic interactions within the galaxy and powerful magnetic lines that most likely influence various star formation and also guide a lot of gas around the galaxy. But these previous discoveries were usually magnetic in nature and almost always vertical, and also mostly served as a direct proof of other observations from similar galaxies, especially with the famous Sophia telescope, that directly show us various magnetic fields and magnetic lines visible in many of these galaxies as well. And a lot of these formations always have these filaments and these beautiful line-like formations that seem to follow magnetic structures in each of these galaxies. So basically this was a kind of an indirect proof of the existence of powerful magnetic fields within each of these galaxies, including the Milky Way. It was never really doubted, but this was a direct proof. But this time, the same scientists, using very similar techniques, but obviously using new improved telescopes, discovered something that even they did not expect. Mystery filaments align in a very different way, almost always along the galactic plane as opposed to vertical to it. And interestingly enough, almost always pointing toward the center, which was very different from previous observations from previous filaments. And here's actually what all of this looks like if you were to combine both. And more intriguingly, implying that there seem to be at least 2 different populations of these filamental strings, and possibly with 2 different origins, with this new discovery almost certainly connected to the central black hole Sagittarius A star. Because unlike other filaments, it seems that these ones are aligned in a way that they kind of point in the direction of the central black hole. And though they're also magnetized and are only visible in radio light, they are different in properties as well. So for example, these previous filaments that do seem to be kind of random and don't really have any connection with one another are definitely different from these ones, which all seem to be tied to the center of the galaxy. And even the scientists behind this paper were actually surprised to find them because they expected all of them to be vertical following the magnetic lines. But unlike these vertical filaments, these new structures are pretty much just short lines. Most of them are only about 5 to 10 light years in length, but there are like hundreds of them, all pointing in the same direction. And although all of them are magnetic in nature, the long structures, the vertical ones, can usually easily accelerate particles to near the speed of light. But these tiny horizontal structures do not. Instead, they seem to emit thermal energy. And more importantly, they're not equally distributed across the galaxy. For some reason, a lot of these newly discovered filaments are mostly arranged on one of the sides of the galactic center, almost as if they're pointing at the radial outflow from the previously active astrophysical jets. The jets that we believe must have been active a few million years ago based on various observations, but that are no longer active now. And more importantly, if you actually trace back when these particular emissions must have started, it seems to have happened approximately 6 million years ago. Which in essence implies that approximately 6 million years ago, something must have formed all of these powerful emissions that eventually produced all of these tiny magnetic lines coming from the center of the galaxy. Which of course implies that our galaxy was probably very active 6 million years ago, emitting very powerful emissions in the process, producing powerful accretion disks and a lot of other electromagnetic effects, and also producing powerful jets that then left behind these unusual filaments. And if this assumption is correct, it actually means that we can now potentially study the accretion disk of the ancient Sagittarius A star. By studying each of these filaments, it might become possible to work out the black hole spin, the size and the power of the accretion disk 6 million years ago, obviously the orientation of the black hole and the accretion disk, and possibly even what exactly caused all of this. And then maybe even work out if this had any effects on planet Earth. It would also be quite important to find the connection between this and the famous Fermi bubbles, although in this case, the Fermi bubbles are believed to have been formed possibly about 2 to 3 million years ago, so there's definitely a bit of a time difference. And though these events might be connected, there's also a possibility that maybe these were two separate events, suggesting that our black hole does this every few million years or so. It basically becomes active, starts spewing out a lot of matter from every direction, creates powerful accretion disks, powerful jets, and leaves behind powerful radio filaments visible from very far away. At least that's one of the first assumptions. The other assumption could be maybe a little bit different. It's also related to a recent study on the so-called Rosetta bubbles, very similar bubbles but only visible in the X-rays that are much bigger, much more powerful, and seem to have been a result of a major star formation in the galactic center and not the activity from the black hole. And so for all we know, maybe these bubbles produced various powerful emissions because of various supernovae all happening at once, which then, as they spread away from the center of the galaxy, produced these radio filaments now visible as the formations that the scientists recently discovered. In other words, the actual origin of this is still not really clear. It was definitely a result of something very powerful and something involving a lot of magnetic interaction, but whether it was star formation, black hole emissions, or something entirely different we don't understand just yet, is a question we cannot answer yet either. But it's definitely something we might be able to answer because of all of these new observations and all of these very powerful telescopes, such as the Meerkat radio telescope that discovered these new formations, that in the next years might help us answer more of these questions about what exactly happened in the Milky Way a few million years ago, and I guess more importantly, if it had any effect on planet Earth. The answer to this for now is most likely no, but that's kind of the question I would like to be answered at some point in the future. One of the biggest cosmological mysteries today is trying to figure out the age of the universe. How old is it exactly? And one of the, I guess, easier ways of doing this is by looking at, well, actually right here, the Milky Way galaxy, our home. By trying to discover some of the oldest objects in the Milky Way, we can then sort of start making assumptions about the total age of the universe, because it's believed that the Milky Way most likely started forming pretty much almost right after the beginning of the universe. But when it comes to discovering some of the oldest objects here, this is of course when things get a little bit tricky. And interestingly enough, something like a couple of decades ago, there was actually an unusual discovery of a star that might have been potentially even older than the universe, kind of. The iconic star HD 140283, also referred to as the Methuselah star. A star that appeared to be, at first, roughly around 14 billion years old, which is obviously older than the universe. But in this case, the age uncertainty was also very, very large. And more specifically, not so long ago, we've discussed another really important study that essentially establishes that the age of the star is much lower. It's now believed to be something like 11 to maybe 12 billion years old, and these earlier calculations were most likely not entirely correct. And so what's the new record holder then in the Milky Way? Is there something else here that we can actually determine to be even older in order to potentially discover the age of the universe? Well, when it comes to individual stars, at the moment it seems to be this one. Relatively complex name, no shorter nicknames, but in essence it's believed to be about 13.5 billion years old. It's approximately 2000 light years away from planet Earth, and it seems to be a star that's a little bit less massive than the Sun, with extremely low metallicity, implying that it is very old. So this is probably one of the first individual stars that formed in a galaxy, or at least one of the oldest remaining stars. But in order to find something even older, and to then calculate the age of the galaxy, we have to look at something entirely different. We actually have to look at some of the most mysterious objects in the entire universe. The objects we know very little about. We have to examine this. Globular clusters. Mysterious formations that seem to be present in most galaxies out there, and the formations that are usually the oldest objects in the entire galaxy. This one being no exception. This is one of the biggest ones near us, known as Omega Centauri. And even though recent examinations by the Gaia telescope discovered that there are quite a lot of stars inside the thick disk that seem to be at least 13 billion years old, implying that the disk most likely formed much earlier than we predicted, around the same time Hubble telescope analyzed one of the clusters right here known as NGC 6652, discovering that its age is most likely much older, at least 13.6 billion years old. Although in this particular case, these types of objects most likely had several generations of stars and several types of star formation, so here we're just talking about the absolute age, or the age when these clusters started forming themselves. And so some stars here are definitely much younger, but quite a lot of stars are actually that old. But much more recently, just a couple of weeks ago, there was actually another study that finally confirmed an even older cluster that's basically just as old as the universe itself, 13.8 billion years old. The cluster you see right here, the very famous M92 or Massey 92, that's around 27,000 light years away from planet Earth, and is located slightly away from the galactic disk. Now, just like so many other clusters, it's actually orbiting in the opposite direction from a lot of other stars, suggesting that it either came from somewhere else, or most likely was born before the galaxy established its rotation. And so in this recent study that you can find in the description, scientists behind the recent study used a somewhat complex statistical analysis, or essentially thousands of computer simulations, in order to figure out what the absolute age of this cluster was, based on the colors it was producing and based on the observations we see so far. And so after 20,000 such simulations, by comparing the colors and brightness, they established that it's most likely 13.8 billion years old, plus minus 700 million years. Although in this case, that error of approximately 5% is actually because we're not entirely certain how far away this cluster is from planet Earth. In other words, there's a bit of a distance discrepancy, which means that we're not entirely sure how big or how small it is. These errors are most likely going to disappear completely once we get additional observations from telescopes like Gaia. And so even though previous assumptions or previous calculations would usually just use a few stars from the cluster to try to determine its age, here the calculations involved the collection of all stars, focusing on the total brightness and the total color coming from this object. Also discovering that its size is approximately 109 light years across, and it has a mass of approximately 330 solar masses. But once again, it's important to remember that this is a collection of stars from different populations, and in this case, in this cluster, at least two populations are known. Some that were most likely created 13.8 billion years ago, but some that were created maybe 6 to 7 billion years ago. So the actual age discrepancy here is pretty large. Nevertheless, by figuring out the age of these objects, it becomes possible to confirm the age of the Milky Way, and more importantly, the age of the entire universe. Because since these are the oldest objects out there, determining their age helps us work out when all of this most likely started. But when it comes to these clusters, it's also important to understand their mysteries and their overall properties. For example, we know that none of the clusters today contain any active star formation. And pretty much all of them in the Milky Way galaxy are over 11 billion years old. We actually know of 150 such clusters, although there are probably more of them hiding, but all of them are super old. And in modern cosmology, this kind of implies one thing. It suggests that there was probably some kind of a very active period in the early universe where huge amounts of these clusters were formed all at the same time, for strange reasons that we still don't understand, and ever since then, they basically remain by themselves in the rest of the galaxy, maybe occasionally interacting with something else, and maybe sometimes forming new stars, but very rarely. So there was basically some kind of a period of globular star formation. And this is a really intriguing period because it suggests that there was something in the early universe that encouraged formation of these objects. Some of the observations from the James Webb Space Telescope might have actually discovered the preliminary signs of the formation of these clusters, but it still hasn't been confirmed. Either way though, they seem to be the first collections of stars to form in the entire universe. And they also represent the densest regions of stars, often containing thousands and even millions of stars, all in a tiny volume of space. Surprisingly, they never really collide, and they all seem to dance around the center without really any major interaction. But because of the proximity of the stars to each other, it's quite unlikely that there are any planets here, or anything more complex than a single star. Even a binary system would not survive here. Actually, there was a potential planet discovered not so long ago around one of the pulsars in these clusters, but it's actually believed to have been captured from somewhere else, and it's most likely just a lost world that was just captured by accident. And so a lot of modern theories suggest that any planets in these clusters very likely escape and become rogue planets traveling across the galaxy. So for example, a direct search for planets in 47 Tucanae cluster came up completely negative. No planets found whatsoever. And because a lot of them often contain only much lighter elements, such as helium and hydrogen, it's now believed that they just lack a lot of heavier elements to create terrestrial planets, or to potentially even create more complex planets we often expect around typical stars. Nevertheless, these clusters are still really interesting, mostly because they seem to have a direct role in galactic evolution that's still not really understood. For example, in many different galaxies, especially elliptical or lenticular galaxies, there's a very unusual relationship between the central supermassive black hole and all of the clusters in the region. The mass of the supermassive black hole is often extremely close to the combined mass of all of the globular clusters. And that by itself is already kind of strange. Nobody knows why this is so. Moreover, there's really no way to explain their formation just yet. We know that they exist pretty much everywhere, and they have a connection to a lot of different galaxies, but how they formed, nobody knows. There are some potential hints from galaxies like the Antenna galaxy right here, where scientists have actually found a cluster of globular clusters that seems to span hundreds of light years across, which potentially shows how they might have formed. So here it will be a collection of different smaller clusters, eventually merging into something larger, where some other answers potentially come from a little bit closer to home. For example, this right here, Westerlund 1, is a region of very large star formation, a kind of a superstar cluster. And so this could be maybe a precursor to globular clusters, or at least something that would have become one if it had a little bit more mass. Here's another really famous one in the Large Magellanic Cloud, known as R136. But at least for now, these are just suggestions, and there's really no way to answer any of these questions until we get more observations from the James Webb, and until we can actually see some of the periods in the early universe directly showing us the formation of these clusters 12 to 13 billion years ago. And of course, based on the observations from this particular cluster, M92, we can now more or less confirm the age of the Milky Way as well, and to some extent the age of the universe, 13.8 billion years. So definitely a pretty exciting discovery, but because we have so many clusters to look at, it will be interesting to see if the scientists discover something else that might be potentially a little bit more mysterious, or possibly create some kind of a mystery when it comes to the age of the universe. We'll see where all of this goes in future studies. There are so many different mysterious objects out there that even today we're having trouble explaining. For example, different types of nebula, different types of galaxies and stars, and of course different types of black holes. But some objects that appear to be normal at first end up being extremely mysterious once you look at them in different frequencies. And today we're going to be discussing one such object. It is a star, but it's probably one of the most mysterious, if not the most mysterious, stars in the Milky Way galaxy. Hello wonderful person, this is Anton. And today we're discussing the star you see right there in the bottom right. The star that doesn't really have a proper name, but is sometimes known as JWST 349, and sometimes is also known as V1478 Sgr A. A very peculiar object that at the moment the scientists cannot really explain because they're not sure exactly what it is. First of all, this object is one of the brightest objects in radio light. It produces some of the brightest emissions visible to us, especially in certain frequencies. It's also some sort of a laser emitter. That's right, it seems to emit lasers, as well as similar phenomena in microwaves known as masers. And more recently, the scientists discovered something else absolutely incredible about this object. But we know that it's most likely a star. Just a super unusual star. A star that might be unique in our galaxy, at least for now. And so let's discuss this object in a little bit more detail and talk about recent discoveries. But first, what do we know about it? So it's an object that's about 4,000 light years away from us, but potentially close to the cluster known as Cygnus OB2. A cluster that, as you can see, is located somewhere right here, and as always represents some kind of a relatively young star formation region where a lot of baby stars are being formed. And so it's always been assumed that this particular star might have escaped from here early on. But that's one of the potential explanations. We're still not entirely sure. What's certain though is that this particular cluster contains a lot of other mysterious objects discovered in a lot of other studies previously. And a little bit farther away from this cluster lies this unusual star with a total mass of approximately 38 solar masses. Although it most likely doesn't look like this at all. But the scientists believe that it's probably a binary or maybe even a trinary star, with both stars being relatively giant and relatively powerful. And a lot of this is based on some of the observations from the light curve of the star, where the variability suggests that something is orbiting around something else, with both stars sort of resembling normal giant hot stars. Although one of them, the primary star, seems to be extremely bright and also seems to possess very large mass loss and potentially some kind of a disk around it. But so far, nothing really unusual. All of this is expected from either extremely young stars or potentially really old stars that have evolved over time to contain somewhat similar features. But apart from these normal observations, there are quite a lot of somewhat unusual observations. For example, as I mentioned, this is also an extremely bright object in radio waves. No other object seems to be as bright as this, specifically in 2 centimeter observations, which seem to create an unusual hourglass nebula. Very similar in shape to what you see right here. But moreover, if you were to look at this object in the infrared light, you would see something very similar, except that it would be 400 times larger, at least 15 light years across. But then, if you were to keep looking at it, you would also start detecting unusual emissions that we refer to as lasers and masers, or light and microwave amplification by stimulated emissions of radiation. Or basically something around the star is causing a lot of optical light and microwave light to become a lot more intense than it would be otherwise. That's the definition of laser. And here it's actually worth mentioning a bit of history. Mostly because masers, or the microwave lasers like the one you see right here at NASA, are surprisingly common in outer space. As a matter of fact, when the scientists originally found them back in the 60s, some scientists believed that it was created by some unusual new substance they referred to as mysterium. They couldn't really understand what's causing these masers. But eventually they found the culprit. It was coming from various hydroxide molecules stuck in various gas clouds around the galaxy. And as these molecules become excited, they end up releasing microwave light, which then becomes amplified as more and more of these molecules start interacting. And lots of sources out there produce masers around the galaxy. It comes from various stars, it comes from a lot of different nebula, and even different comets, planets, or even interstellar space and intergalactic space itself. But this odd star was producing lasers as well, and it's most likely produced in the way that you see right here. Some kind of an accretion disk, very likely containing a lot of different gases, seems to produce amplification of different frequencies of light, making the star already really strange. Brightest radio object, and the object that seems to be shooting out lasers and masers toward planet Earth. And if the light coming from the star had any pattern, I'm sure someone would already thought this was some kind of an alien civilization. But based on the observations, the emissions are definitely very natural. So it's really something coming from within the disk around the star and from the star itself. But so far all of the observations really suggested that there has to be some kind of a disk of material that was not ejected from the star and was orbiting around it, producing all of these effects, while at the same time experiencing a lot of interaction with very powerful emissions coming from one of the stars. It's actually believed that the star here lost at least 15 solar masses because it's extremely active. Yet despite all of these observations, there was always one mystery about the star. Nobody knew exactly how old it is. Is this some kind of a super young star that's just super active? Or is this an old star that's very similar to a typical Wolf-Rayet star that's going to go supernova really soon? And so a lot of different studies have been trying to focus on trying to figure all of this out. And one of the studies recently discovered something else really unusual. Something that was discovered while looking at the masers and analyzing how they reflect from various regions around the star. Turns out that the star is also emitting a tremendously powerful jet, with the material traveling at approximately 500 km per second. And the disk around the star seems to be at least 50 astronomical units in diameter, actually kind of similar to the solar system. And this observation is similar to a lot of other really young stars, such as the HH objects we've discussed previously, that very often possess extremely similar jets, with stuff just coming from both directions emitted from the star. And intriguingly, all of this is magnetic in nature. A lot of these interactions are essentially a kind of an interplay between the magnetic nature of the disk and the super powerful magnetic fields inside the star. And because of the interaction of all of these magnetic forces, it sometimes makes the star extremely small at the end, but in other times ends up feeding the star so much that it becomes an extremely powerful giant. But normally these jets are responsible for throwing off a huge amount of mass. And based on the observations in radio light, we can only assume that the magnetic fields here are super powerful. But the star system in this case is still a little bit strange. There's still a lot of different effects that a lot of other stars don't seem to have, and a lot of other features like lasers and masers that we don't really see that often coming from a single object. Although it's also possible that maybe we just got lucky with the orientation of the disk itself. And here the scientists suggest that maybe it's actually because the disk is just positioned toward us, and so the lasers and masers leaving the disk eventually cross the path with planet Earth, making all of this a lot easier to see. And it was because of these masers that all of these other features were discovered in the recent study. But I guess the question is, so what's the conclusion? What sort of a star is this? Well, so far it does look like this is a really young object that was probably kicked out from that Cygnus OB cluster and eventually started to travel by itself, acquiring all sorts of unusual properties as the major star started to lose a lot of mass. But if this was something common, we'd be seeing this all over the place. So far, this is the only such object known to us, and so finding these exceptions is really what makes astronomy so intriguing. For all we know, in the next few years, the scientists might discover something else really intriguing. And for all we know, these super powerful radio emissions might be actually caused by something entirely different. And so the origins of this unusual star, MWC 349, are still a little bit mysterious. So I'm sure most of you are aware of constellations. You know, you have your Sagittarius, Scorpius, Capricornus, and so on and so forth. But to NASA scientists, these are usually known as the optical constellations, something that's only visible in the optical light. But if you've been watching a lot of videos on this channel, you're probably aware that we also have the infrared map of the universe, we have the microwave map, the radio map, X-ray map, and more excitingly, the gamma ray map. In other words, the actual night skies will look completely different in various frequencies. You can learn more about these maps in some of the previous videos in the description, but today we're focusing on new discoveries in the gamma ray frequencies. Hello wonderful person, this is Anton, and so today we're going to be discussing the potential solution to the Fermi bubble mystery. The strange bubbles, discovered back in 2010 by the gamma ray telescope known as Fermi, that discovered these unusual structures emanating from the center of the galaxy. But before we talk about the mystery and the explanation, let me actually just go back to that map I showed you previously. So this map right here that was made by NASA a few years ago. And here we have optical constellations, but we also get gamma ray constellations. Basically, in the last few years, the scientists have also proposed a bunch of gamma ray constellations only visible in the gamma ray light. But in this case, because these are modern constellations, for the most part they have really geeky, really nerdy, and somewhat funny names. And by the way, this is an actual thing, this actually exists. The link for this is in the description below. So here we have the Fermi constellation, named after the Fermi satellite, but as you can see next to it we have the Targus constellation. Hopefully I don't have to explain where this is from. Right above it we have the Hulk, we have the Eiffel Tower, the Little Prince, the Obelisk, Saturn V rocket, and my favorite, the Godzilla. Sort of looks like this in the actual constellation, and this is with the artwork. There are a bunch of other ones, some of them are really funny, once again in the description, but the point here is that we've discovered so many different gamma ray objects that the scientists had to start proposing different names in order to identify them easier. Starship Enterprise, for example. But by looking at this with more sensitivity, we'll actually start seeing something a little bit different. Here's roughly what you see with the diffuse gamma ray light. And notice how there are these two unusual structures going below the galaxy and above the galaxy itself. Or let's be more specific here. Covering the Mjolnir constellation, the TARDIS constellation, the Fermi satellite constellation, and the right hand of the Hulk constellations. And that's what we call the Fermi bubbles. But more intriguingly, by looking at these structures in other light, the scientists started to discover other formations as well. This is in the X-rays, suggesting that these structures are very likely connected. And in this case, this was only discovered back in 2020, 10 years later. And so almost right away to the scientists, this implied one thing. Something extremely powerful must have happened in the center of the Milky Way to produce these formations. And because a lot of similar formations have been observed in other galaxies, with many of them already explained very thoroughly, the origin here was most likely due to the supermassive black hole right in the center of the Milky Way. And so that's what the scientists have believed for the past 12 to 13 years. But it wasn't entirely clear what produced this though. It was not really argued that these were from the central black hole, but the actual event was not clear. For example, was this some kind of a tidal disruption event, where a star comes really close to the black hole and becomes absorbed in the process? Or was this something related to much longer events, such as the ones we usually observe from radio galaxies? Or maybe something entirely different, producing various galactic winds? So the actual origin of Fermi bubbles was not entirely clear. But because gamma rays are generally produced by extremely powerful events, whatever caused it had to be very powerful as well. And this is like 50,000 light years across, and visible in both gamma rays and X-rays, so there's a lot of energy involved here. So what exactly could have happened here around the central black hole to produce all of this? And in the past, several scientists have tried to answer this question, but their answers were not super conclusive. This time though, this Japanese scientist decided to try to answer this by using a combination of modeling, simulations, and of course mathematics, in order to provide us with a relatively good answer, and actually a potentially important answer that we need to consider. So here's what he discovered. His explanations and his modeling actually explains both the gamma ray and the X-ray emissions. And he found that all of this seems to be caused by fast-moving wind slamming into the gas in the galaxy that ends up producing very specific shock waves through the collision of charged particles with the interstellar medium. And as these shock waves bounce around, they create a lot of reverse shock waves that then heat up the material and produce the X-rays and the gamma rays observed. With a lot of this new data coming from the Japanese Suzaku satellite that provided even more X-ray data. And when tracing all of this back in time to the source, it becomes clear what most likely produced this. Long-lasting galactic winds with the expelled material moving at the speed of about 1000 km per second, but lasting for about 10 million years at least. And that's why, of course, these bubbles are about 50,000 light years across, and why we're still seeing the emissions even today. This is basically a result of about 10 million years of activity. However, when he tried to reproduce the same effects by using just one collision or some kind of a tidal disruption event, or essentially when a star gets destroyed by a black hole and produces really powerful emissions for a relatively short time, he was not really able to reproduce the same observations, meaning that the Fermi bubbles are not likely created by something like this. And so if not tidal disruption events, it had to be much longer galactic winds that we've seen from so many different galaxies already. And if the scientist in this case is correct, it suggests that all of this very likely finished relatively recently, within the last few million years, and possibly even within the last 3 million years. Which of course has a bit of an implication on what effects this might have had on the atmosphere of planet Earth. For example, is there any way we can maybe explain some of the previous climatic changes by the detection coming from the Milky Way center? Although it's actually important to understand that galactic winds can be caused by at least two separate events. In this case, you're looking at MA2, an iconic galaxy with visible galactic winds. But the galactic winds here are not caused by the central black hole. They're caused by a dramatic increase in starburst activity, various stars being created exploding as supernova and creating extremely powerful pressure events that end up pushing a lot of the gas into the intergalactic space. Something that could have happened in the Milky Way galaxy as well, and so it's not super clear if the Fermi bubbles were produced by the black hole or by some kind of an increase in star-forming activity. But if this was produced by a black hole, it means that Sagittarius A star's supermassive black hole can occasionally become superactive, potentially consuming huge amounts of gas coming from somewhere else in the central galaxy, and doing so for at least 10 million years. And so exactly what caused the galactic wind is not super clear just yet. Nevertheless, these events are usually really important for the galactic evolution. They tend to distribute a lot of materials throughout the galaxy and also regulate star formation in other regions. Sometimes they can stop star formation, sometimes they can create pressure waves to start star formation somewhere else. And at the same time, it blows a lot of material into the halo of the galaxy, which sometimes returns back into the galaxy later on, providing more materials to the outskirts or starting more star formation in farther away regions. And so it's actually a super complicated process that the scientists still don't really understand really well, but it's something that's definitely going to affect the galaxy in the next few millions of years. Although in this case, because the wind was extremely slow and steady, and also because it seems to emanate in two separate directions, kind of similar to a typical black hole emission, it's a lot more likely that all of this was probably caused by Sagittarius A star. It's obviously not clear where all of this material came from, but it must have come from somewhere. And here you had to have a lot of material to feed the black hole. Remember, this lasted for 10 million years. And the wind is still traveling away from the center even today, with a velocity of about 1000 kilometers per second. So definitely a pretty good explanation. But now I'm genuinely curious what effects this might have had on planet Earth, if any. And more intriguingly, if this is galactic wind, it probably also came toward planet Earth as well. I mean, the distance from the top to the bottom here is about 25,000 light years, and the distance from the central black hole to planet Earth is around the same as well. And so it would definitely be interesting to find out what effects, if any, this would have on our planet. But today, Sagittarius A star is a really timid, really quiet black hole, compared to the ones in other galaxies. And so whatever caused the Fermi bubbles seemed to be a rare and unusual event. Today I wanted to discuss this relatively recent discovery of a very peculiar nebula. Although in this case it's not the nebula that's strange, it's what happens inside of it. This nebula seems to pulsate every 4 years, changing in color and changing in brightness. And though unfortunately there are no videos of this yet, in some sense it potentially resembles something like this. And this is a really interesting phenomenon that we're going to be discussing in this video. It's known as the light echo. The very strange phenomena that happen all over the place, that are usually caused by light interacting with certain gas, making it shine in the process. And though we've actually seen this happening all over the place many times, some of these light echoes are really extreme, and some are actually kind of mind-blowing. And some of them might even appear as they're defying the laws of physics, with the best example being this, V838 Monocerotis, that surprised the scientists back in 2003. And here, if you actually measure the distance, it appears as if this bubble is moving faster than the speed of light, up to about 7 times faster as a matter of fact. But this superluminous motion phenomenon is very well known, and so technically it's a kind of a visual illusion, and you can learn more about this in one of the videos in the description that talks specifically about this example and a few other examples from the rest of the universe. Because today I really wanted to focus on the light echoes themselves, and really mostly because of this new example. But first let's actually talk about how all of this was discovered, because the survey that conducted this is also pretty interesting. It's known as Triple V survey, or Vista variables in the Via Lactea, that essentially collected data for approximately 10 years in total. And its purpose was really simple. It actually tried to look at the center of the galaxy, and specifically the Milky Way's bulge, in order to discover as much as we can about this region, but also to try to see through it by piercing through all of this gas. We actually refer to this as the zone of avoidance, and it's called that because it's very difficult to see behind it. All of this gas prevents any light from moving through, and so quite a lot of objects, including the famous Great Attractor behind this region, remain kind of mysterious because we can only observe them in certain frequencies. and one of these frequencies is infrared, which is why very recently the James Webb Space Telescope has also begun observations in this particular region. But during this 10-year survey, quite a lot of objects were discovered in the process, actually billions of objects. And some of them at first did not make any sense. And the first object that nobody could explain was discovered back in 2010. It was actually found pretty quickly because it suddenly changed in brightness, but did so in a very strange way. And so this object became known as WIT-01, the first unusual object, with the acronym WIT just meaning, what is that? And this was accidentally coined by the astronomers, and this kind of stuck because every other object discovered that made no sense now just basically had a different number. Now the first object we discovered has now been potentially resolved, and it just seems to be some kind of a classical nova, very likely hiding behind some kind of a cloud. The second object was some kind of an outburst that still has not been explained very well. Then there are a few other ones, but some of the more exciting ones were actually discovered just a few years ago. For example, Sgr A turned out to be another unusual dimming star, very similar to the Tabby star. But even though Tabby star only dimmed by about 20%, this star dimmed by about 80%. We've discussed this in one of the older videos, but in essence, this is still kind of unexplained, but assumed to be a result of either A, a lot of dust, or B, potentially rings, and we're talking about really large rings, that essentially cover a large part of the entire star system, very similar to the famous star known as Mamajex object. And so this was maybe one of the potential explanations here. Ironically, the next object, 08, turned out to be even more extreme. Here it dipped by about 97%, almost disappearing completely. And this is completely unexplained as of today. I think there's a video in the description that discusses this in a little bit more detail. But now we have this new object, number 12, once again discovered somewhat by accident when exploring this older data. Although here, the original observation was of the star in the center. It turned out to be a variable star that basically increases and decreases in brightness roughly every 4 years. But when the scientists analyzed the region around the star, they discovered that the region around the star was changing color with a relatively similar period, but did so differently depending on where you look. Interestingly, when the side closer to us got brighter, the side on the opposite side got dimmer. By why this was happening was not clear. But it was pretty clear what we're looking at. Very likely an extremely young star in the process of forming that also seemed to be variable, changing in brightness every 4 years. And because many of these young stars will often contain a very large nebula around them, with most of the gas just being leftovers from the star formation, or sometimes even emitted by the star itself, here the preliminary conclusion is that it's just a young star with a somewhat unequal cloud around it, but also a star that produces very powerful emissions, like so many young stars usually do, illuminating the clouds and creating these light echoes. Or at least that's the preliminary explanation for now. It definitely makes sense, but we might discover something else in the future that might provide additional information. For example, one thing future studies might do is conduct a chemical analysis, or some kind of a spectroscopic analysis, in essence revealing exactly what's going on in these clouds. Right now though, it basically looks like some kind of an extremely red star with a period of 1525 days, which is to some extent what you see right here. Although honestly, I really can't wait to see this as some sort of a time-lapse. I'm sure it's going to look really impressive, just like the star you see right here. And though this particular example is definitely pretty strange when it comes to light echoes, it is not the strangest by far. Technically, this phenomenon exists all over the place, but it's hard for humans to see it because it only manifests over astronomical distances. Here you would have to take a time-lapse for at least several months in order to see what's going on. But it is actually a very useful phenomenon because it allows us to study the universe, and specifically our own galaxy, in a way that would be completely impossible otherwise. For example, we can actually discover various ancient supernovae by studying these light echoes, because they basically represent reflections of the light as it strikes various clouds. I think the best example here is the famous Tycho's supernova, also known as SN 1572, which represents one of the most studied supernova remnant ever. But by observing light echoes at a distance of just over 400 light years away from the supernova remnant, the scientists were able to confirm that not only was this a Type 1a supernova, but were also able to discover a lot of other features, and of course confirm its age, by just observing the light from the supernova that traveled for 400 years reflecting off a distant cloud. And so all of these reflections, with the light traveling for 400 years, suddenly became visible back in 2008. As far as I know, they're still visible today as well, but they will disappear with time. Another really intriguing discovery only happened a few years back. This was actually a detection of an unusual light echo extremely close to the center of the galaxy. It was coming from the central black hole and was essentially creating very powerful emissions at a distance of 350 light-years in one of the nearby clouds. And by measuring these emissions, and basically by looking at the echo in different frequencies, researchers realized that 350 years ago, the central black hole of the Milky Way galaxy very likely had a very massive emission, at least 1 million times more powerful than anything seen today. And though it's not clear what caused this, it was pretty clear that it happened because there was no other way to explain these extremely powerful light echoes with the light suddenly reflected by super powerful radiation coming from the central black hole. And so basically here, as it travels away from the central black hole for many years, it's going to create even more light echoes, very likely even allowing us to create some kind of a three-dimensional image, explaining this phenomenon a little bit better. But there is something even more extreme when it comes to light echoes that was actually discovered completely by accident by an amateur or independent astronomer. Actually not even an astronomer as much as a school teacher, Hanny van Erkel from Netherlands. And you can read more about this in the blog in the description, but essentially she was a citizen scientist for the Galaxy Zoo, an extremely large project that's been going on for many years now. And here, completely by accident, she discovered a very strange object. The object you see right here in green, and she called it Hanny's voorwerp. Voorwerp is Dutch for object, I think. Anyway, this seemed to be some kind of a rare astronomical object, appearing as a very bright blob, only visible in certain frequencies. Now here we see it as green, but this was dramatically enhanced. It's actually green because of ionized oxygen. But in terms of size, this was pretty big, 16,000 light-years across. And naturally, created a bit of a mystery, but the mystery was solved pretty quickly. Mostly because a lot of other similar objects were discovered in a lot of different galaxies, now referred to as voorwerps. And in every single case, they were somewhat similar in appearance and suggested something very similar going on here. That something was very likely illumination from the central black hole. And though in some cases this illumination was basically forming these enormous clouds, that original object very likely was created for a slightly different reason. Here the scientists believe it all started with the galactic passage, where a smaller galaxy very likely fell apart, creating what's known as a tidal tail. There are quite a lot of them around the Milky Way as well, so these are actually pretty common. But then at some point in the past, temporarily became a quasar, or essentially became an active galactic nucleus, creating two powerful jets. One of these jets seemed to have illuminated this tail, forming the beautiful light echo, but also surprisingly initiating star-forming regions, with many stars observed here actually being relatively young, only a few million years old. And here the explanation is that not only did the quasar produce the powerful jet, it also very likely emitted huge amounts of dust that formed these very powerful waves that traveled away from the black hole, interacting with the gas from the tidal tail, and then forming overdensities, beginning star formation. And though it might sound a little bit complex in terms of an actual explanation, it really makes sense, and it makes sense for one simple reason. Something very similar was discovered right here in the Milky Way, with a former jet from the Milky Way's black hole illuminating the stream known as the Magellanic Stream. And you can learn more about this in one of the videos in the description. And this by itself was a pretty big discovery, because here there's a lot of activity, including star formation as well. But it also highlights that these unusual objects, or these galactic light echoes, seem to be pretty common. And more importantly, it highlights how exceptionally useful they are for studying the history of various galaxies or the histories of supernova, star formation, and so on. And so light echoes are not just gorgeous, they're also exceptionally useful for modern astronomy. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries coming from the center of the Milky Way galaxy. The region extremely close to the central black hole, Sagittarius A star, and the region that we usually refer to as the central molecular zone, or essentially the galactic center. The location where 2 decades ago the scientists discovered the central black hole, but in the process also discovered quite a lot of really powerful emissions coming from a lot of other powerful objects. some which are still not entirely understood. And since there is so much activity going on inside this region, discovering new things is always expected. But in today's video, we're actually going to be focusing on one particular discovery. Another really intriguing black hole, but not a supermassive black hole and not a typical solar mass black hole. Instead, an elusive intermediate mass black hole that sort of lies in between them. An object that theoretically is anywhere from a few hundred to a few thousand solar masses, and an object that the scientists have always believed forms a fundamental building block of much larger, more massive black holes. But to date, only a handful of potential candidates have been discovered with no official confirmation just yet. As a matter of fact, the smallest intermediate mass black hole, almost definitively confirmed to date, was a result of a collision of two solar mass black holes that resulted in something that's approximately 140 solar masses. You can learn more about this detection in the video in the description. But everything else to date has always been kind of speculative and only based on certain observations from various effects these black holes create around them. No definitive evidence exists just yet. But the scientists do expect a lot of these to exist out there because they're supposed to be building blocks for much more massive black holes. Yet where are they? Where are they hiding? Why is it that it's so difficult to find them? For example, in the past, a few scientists suggested that maybe some of them are hiding inside globular clusters. For example, M31G1 cluster, the one that you see right here, was suggested to host one in the middle because of the very fast velocity of certain stars. But other studies suggested that all of this is possible without a black hole, so nothing so far has been even found in globular clusters. Other studies suggested that certain locations known as ULX, or ultra-luminous X-ray sources, were supposed to contain these black holes somewhere in the middle producing these observations. And these are very often found in various starburst galaxies, like the antenna galaxies you see right here, in locations where a lot of stars are generated all at once. But once again, it's possible that all of these emissions are produced by something entirely different. And even after analyzing approximately 300 candidates using various X-ray observations, only 10 potential candidates have been found. But these are just candidates. They have to be confirmed, they have to be reanalyzed. So far, nothing like this has been done. Although intriguingly, certain galaxies, like this one right here, NGC 4395, seem to actually contain smaller black holes in their center. Instead of a supermassive black hole, the one here is a little bit on the smaller side. It's approximately 10 times smaller than the one in the center of our own galaxy, and is about 360,000 solar masses. And so technically this is an intermediate mass black hole, but at the same time, because it's a central black hole, it sort of implies that this was once again a location where various intermediate mass black holes combined into a larger one, but there was probably just not enough of them to create a supermassive black hole. So in some sense, this is more of a failed supermassive black hole as opposed to anything else. But when it comes to finding these black holes, it's actually a lot more important to try to look for them here in the Milky Way or in our vicinity. And so far, once again, there's only been some speculations, nothing official just yet. For example, in 2001, the scientists studying the Andromeda galaxy discovered that at least one globular cluster here has a very high chance of containing a black hole approximately 100,000 solar masses. And so far this is a pretty strong candidate. But a much more intriguing discovery came from a Japanese university back in 2015. And this was actually right here in the Milky Way, very close to the center of the galaxy. When the scientists took a look at a gas cloud that you see right here, they discovered that the dispersion velocity of the cloud particles suggested that the gas here was moving a little bit faster than it should be moving, as if something really massive was pulling on a lot of those particles, accelerating them and creating these unusual formations. That something was suggested to be an intermediate mass black hole, approximately 100,000 solar masses. Although additional observations and additional calculations have also suggested that maybe this is actually a result of a large number of supernova that accelerated all of this over the past few thousands and millions of years. And because the velocity here was not in any specific direction, it was kind of challenging to prove that this was a black hole in the middle because there was no other observations otherwise. In other words, the scientists did not actually see any emissions coming from this region, indicative of a massive black hole. Nevertheless, the scientists from this university did not give up. They essentially kept looking for more signs of whatever is happening here, mostly because the theory of black hole formation predicts that these central regions should actually contain quite a few of these intermediate mass black holes, orbiting the central supermassive black hole, essentially providing the necessary material for the black hole to grow larger over time. But obviously, because all of this is like 27,000 light years away from us, it is relatively difficult to see all of this, especially because there is so much stuff going on here already. A lot of these emissions could potentially have a lot of different sources, but nowadays it's a little bit easier to discern some of these objects because of much higher quality of telescopes and a lot of different super detailed surveys of this region. And so by using some of the new data from the James Clerk Maxwell telescope, located in Hawaii, along with the Japanese Nobeyama 45-meter radio telescope, the scientists behind this recent study were able to collect more detailed data, discovering a lot of new features nobody has seen before. And specifically, within a few light years away from Sagittarius A star, the massive black hole, they discovered an unusual feature they are currently referring to as the tadpole, mostly because of the shape that it seems to possess. When zooming in on this object, it sort of looks like this. Now this is a very unusual shape. As a matter of fact, it's an unusual shape that's very difficult to form naturally. And this is actually kind of related to the video I've recently posted about a supermassive black hole discovered traveling in the intergalactic space that also produced a telltale sign of something really massive passing through a region of space, with the best explanation being, of course, a black hole. A black hole that seems to have caused star formation along its pathway. But in this case, this unusual tadpole seems to be a result of something really massive stretching the object, creating something that seems to orbit a central point with a very specific dispersion velocity. And based on the velocity of individual particles, the scientists in this paper concluded that it can only be a relatively massive black hole, approximately 100,000 solar masses, or essentially a stereotypical intermediate mass black hole, because it would be very difficult to produce this shape in any other way. But just like with previous observations, once again, the actual black hole does not seem to produce any effects. And so when the scientists zoomed in on this and tried to analyze this location in various frequencies, they unfortunately did not see anything here. No X-rays, no infrared, no radio light, absolutely nothing seems to be emitting any light, as if there's nothing there. Yet it does seem to produce gravitational effects expected from a really massive object. And so to the scientists behind this paper, it basically suggested that it's very likely an inactive intermediate mass black hole. A black hole that's about 100,000 solar masses, but doesn't produce any emissions because there's nothing around it, and in terms of the actual physical size, would be the size of a large gas giant planet like Jupiter or Saturn. But because there are no observations coming from the vicinity of this region, it's still just a candidate and actually presents a bit of a mystery, because for all we know, it could be some other really massive phenomenon, such as maybe a chunk of dark matter or something entirely different. In other words, the idea that it's a black hole is still only a suggestion, and a suggestion that's based on a lot of predictions and a lot of theories. But because of the size of this tadpole, approximately 3 to 4 light years across, and because the velocity of particles here seems to be about 50 kilometers per second around a central point, at the moment some kind of an invisible massive object is really the best explanation. It would be very challenging to explain these unusual tidal effects otherwise. So I think in the next few months we're going to be talking about my most favorite region in the entire galaxy many times. The central region, the galactic center. The region that kind of looks like this if you were to look at it using some kind of a time-lapse. You can sort of see a lot of stars orbiting the center, and that's of course Sagittarius A star, the supermassive black hole right in the middle of our own galaxy. But the reason we're going to be discussing this region quite a lot is of course because a lot of studies using James Webb Space Telescope are now focusing on this specific region, because James Webb was able to conduct a lot of detailed observations from here and is going to be doing even more in the future, and also because James Webb is an infrared telescope. It's able to physically see through all of this dust and actually reveal what's on the inside. And naturally it's already made some really incredible discoveries, the ones we discussed in one of the previous videos that should be somewhere in the description. But today we're going to discuss a few more discoveries, and some that actually are sort of surprising. Turns out that at least one of these stars is very likely not from this galaxy. It came from somewhere else, traveling for approximately 10 billion years from a distant galaxy that no longer exists, with additional discoveries from this region you see right here, often referred to as the brick. And so, hello wonderful person, this is Anton, let's discuss the central region and discoveries from the black hole once again and talk about exactly what's happening here based on recent observations. But first, let's start with the basics in case you've never heard about this region before. In this case, this is the region of the second picture from a black hole taken by the Event Horizon Telescope team. This is basically what we think the region around the black hole potentially looks like, at least in radio light. These are radio emissions, so this is obviously not optical light. But more importantly, for decades now, the scientists have been observing the motions of the star in this region, eventually realizing or basically confirming that there is a really massive object right in the center. The confirmation for the existence of Sagittarius A star, supermassive black hole, with a mass of 4.3 million solar masses, and a few scientists won the Nobel Prize for this a few years ago. But one question that was not answered before, and one question that's, I guess, sort of important is, so these stars. There are so many of them here, but where exactly did they actually come from? What's the origin of all of these stars very close to the black hole? And I guess more specifically, is there any chance that some of them were actually formed here, or did they all migrate from somewhere else? Now, quite a lot of these stars, especially the ones very close to the supermassive black hole, have a name. They're known as S stars. And I think the most famous one must be S2. Or I guess more specifically, the most studied and the most well understood. Its orbit is known exactly, and it was even used to prove a lot of Einsteinian ideas that basically show us how some of these stars have a very unusual precession that would not exist unless there was a very massive object in the middle. And so this star is definitely there, it's quite well understood, it has a very unusual eccentric orbit, and it seems to orbit in this way. Although this is obviously accelerated, with the true orbital period being approximately 16 years. But because the environment around the black hole is so extreme, nobody actually thinks these stars formed here. And at least there's no way to prove this or to even explain this. And so they must be migrant stars. They must have come from somewhere else. Interestingly, at least one video in the description talks about one of the most extreme S stars out there. At its closest approach, it moves around the black hole at the speed of approximately 24,000 km per second. That's a very fast star, basically nearly 10% of the speed of light. But how can these stars get these unusual orbits, and where are they from? Well, at least one recent study managed to discover the potential origin of one of them, and it's nothing anyone imagined. Here we're talking about the star known as Sgr A. It orbits approximately 0.04 light years away from the black hole, and surprisingly, it seems to be a really old star. Its age was determined to be over 10 billion years old. That's double of our own sun. But more importantly, by using the Japanese Sgr A telescope, the Japanese researchers measured the quantity and ratios of various elements inside this star, determining that it looks very different from a lot of other S stars. Specifically that it seems to be not from the Milky Way. Or basically that its composition is just very different from anything we expect in this region or even in our own galaxy. Instead, its composition was very similar to what we usually find in various dwarf galaxies around the Milky Way. Somewhat similar to the famous Small Magellanic Cloud that actually does have a lot of ancient stars and somewhat primitive elemental composition, mostly because the material inside this galaxy is somewhat pristine and somewhat untouched, but it seemed to match even closer to the galaxy that used to exist but no longer does. Here the composition was extremely similar to stars in Palomar 12, a star cluster somewhat far away from us, and similar to Messier 54, a really famous globular cluster that's located a little bit farther away from the Milky Way, but we know came from a different galaxy. A galaxy whose remains are still here, Sagittarius dwarf galaxy, that you sort of see right there. This unusual galaxy used to exist a long time ago, here we're talking about something like 10 billion years ago, and was a little bit smaller and a little bit less massive than the Milky Way. Eventually the Milky Way won the, I guess, a kind of a tug of war, and slowly absorbed a smaller galaxy into itself. And we still see the signs of this absorption and this galactic cannibalism even today. This is known as the Sagittarius stream, and pretty much all of these clusters and all of these leftovers are still in the same location today. They're orbiting as a kind of a very long formation around the Milky Way, and will eventually get absorbed into it with time. And surprisingly, or I guess maybe not surprisingly, all of the stars in the stream and all of the stars in these various formations seem to be almost exactly similar in composition to this star, that just finds itself right in the middle of the galaxy. And it's about 10 billion years old. It's almost identical in chemical composition to everything else, which leaves us with only one possible conclusion. It must have somehow ended up here as the galaxies collided and as one star escaped Sagittarius dwarf and with time moved closer and closer and closer to the black hole, eventually assuming a very tight orbit around it. We don't really know exactly how long this process took, but it very likely has been here for quite some time, possibly even billions of years. Or, for all we know, maybe it actually traveled through the Milky Way for billions of years and has only arrived to this region recently. Mostly because we know that this region is somewhat hectic and there's a lot of gravitational interaction with a lot of other stuff, and so honestly nobody actually has any idea how long a typical star here lasts orbiting around the black hole before being dislodged and possibly thrown out of the galaxy, or falls into a black hole, forming some kind of a super massive emission event. Like the one responsible for the famous Fermi bubbles that must have formed approximately 2.5 million years ago. And so by itself this is not an unusual proposition, because we kind of expect some stars to maybe make their way toward the center. And obviously we expect galaxies to be swallowed as well. But I guess nobody actually expected to find one. The theory is theory, but here we physically find a star that must have come from a different galaxy destroyed by the Milky Way. So this is our first observational evidence that this seems to definitely happen. But there was actually an additional study of other stars nearby that was slightly farther away from this region and were also just as surprising. And here the scientists analyzed 3 more stars that were kind of unusual in terms of their composition and in terms of their age, discovering that all 3 seem to be much younger than what we actually expect, anywhere from 100 million to possibly 1 billion years old. And the reason this is unusual is because it kind of suggests that, maybe just maybe, there is definitely a lot of active star formation going on very close to the black hole, possibly formed as various very cold clouds collapse under gravity, creating various overdensities that then lead to new stars. At least that's the theory behind this. But when it comes to physical observations, we don't really see as many. As a matter of fact, the physical observations seem to be lacking. And so this recent study took a look at one of the potential regions that should be forming stars. This is known as the brick. As you can see from this image, it's not really that far from Sagittarius A star and from the central region. And so because it's so close, and because it's actually filled with gas, we kind of expect it to produce stars. This is an extremely thick region with a lot of different gas. And the recent discovery from the James Webb highlights even more that we expect this region to be a star-forming region. Here the scientists discover a massive amount of carbon monoxide, CO, way more than anyone expected, and basically just as much as we usually expect from a typical molecular cloud forming new stars. Normally, carbon monoxide forms ice particles, which then slowly coalesce and become larger and larger, eventually becoming planets, stars, and star systems. Yet nothing like this is seen around the brick. It seems to completely lack star formation, despite all of the necessary prerequisites. Especially because we know that stars seem to form here, so why not the brick? And it looks like at the moment we don't really know, but one potential explanation involves temperature. It looks like the brick is not as cold as it should be in order to start forming stars. Or basically, a lot of gas in the region here seems to be much warmer than it should be, very likely because of all of the activity from nearby stars and from the black hole, which sort of prevents certain regions from suddenly forming stars. If the gas is too hot, star formation is impossible. But we know that it seems to happen in other regions nearby, so there are basically some unexplained elements here, or unusual mysteries that nobody can explain just yet. But because the brick itself is so thick in dust and various materials, but does not have any stars or any star production, that's why it basically looks so thick, so dark, and so opaque. And why a lot of scientists want to understand exactly what's going on here. But at least for now, we still have some really exciting discoveries in regards to stars that were discovered, and the first ever extragalactic star that seems to orbit super close to the center. Another extreme S star to add to the list of extreme stars around the black hole. Hello wonderful person, this is Anton, and today we're going to be discussing new discoveries coming from our own galaxy, the Milky Way. And some of these discoveries are somewhat unexpected. And I guess the main discovery here is in regards to the shape of the Milky Way, that we might have once again been a little bit incorrect about. With all of this, as always, coming from the study you can find in the description below, with a title, What does the Milky Way look like? A question that's surprisingly difficult to answer because we're observing everything from within the Milky Way itself. And if you've been on the channel long enough, you know that there have been quite a few times when the scientists realized that we might have been incorrect about certain assumptions when it comes to the shape of our own galaxy. For example, in this simulation that you see right here, using Space Engine, this is an extremely outdated and even somewhat primitive representation of the galaxy that does not describe Milky Way very well. As a matter of fact, this most likely does not look like the Milky Way at all. With even some of the older videos by the European Southern Observatory that usually produces accurate observations of everything, presenting this as a potential representation of the Milky Way. But this image by Pablo Carlos Budassi, a really brilliant artist, presents the Milky Way shape in a slightly more accurate way. First of all, as you can see, the galaxy is most likely warped. The warp in this case is a result of interaction with a lot of other galaxies previously. Second of all, our galaxy contains these unusual streams from interactions of smaller dwarf galaxies in the past. And there's also, of course, a relatively large halo that should be visible from farther away. But in certain other frequencies, you're also going to observe signs of previous eruptions, the Fermi bubbles, that are visible in the X-rays, gamma rays, and even radio light. But what about from the top? Well, the assumption here has always been that our galaxy is a spiral galaxy with possibly 4 arms. Possibly resembling something like this, the galaxy known as UGC 12158. But the majority of older studies, and the analysis from older observations, imply that there seem to be 4 galactic arms extending from the center that contains a galactic bar. These are the Perseus arm, the Norma and the Ara arm, Scutum Centaurus arm, and Carina Sagittarius arm. And possibly even the 5th arm known as Orion Cygnus, and a lot of other small arms we've discussed in one of the previous videos somewhere in the description. Although the main point here is that a lot of scientists in the past assume that there are 4 main arms, maybe 5, but probably 4. Which, though makes sense, is statistically very unlikely. Here's actually what we usually detect from various spiral galaxies, extremely similar to the Milky Way. Out of approximately 100 different galaxies, only 2 are known to have 4 arms. Only 1 is known to have 5 arms. The majority of galaxies out there, especially if it's a barred galaxy, is only going to contain 2 arms. 2 main arms and possibly a few smaller ones. And that's of course statistics. And so the scientists behind this study wanted to actually find out if our observations are correct or if the newer observations might basically redefine the amount of arms. In this case, focusing on various types of state-of-the-art interferometry observations, which usually use microwave to measure accurate distances to various stars, on top of new observations from the iconic Gaia telescope that's been mapping the night skies for the past few years. And so by combining the data, they were able to establish that, yeah, we were probably wrong. It might be 2 arms after all. For example, here by using 200 extremely bright OB stars that generally don't really move much after their formation, they were able to map the exact location for various arms. These are usually produced inside arms and not in between them. And by combining and confirming this with the Gaia telescope observation that provided them with 24,000 other stars, they essentially started to build a much more accurate picture of what's actually happening here. And by recreating the position of these stars across the galaxy, they started to work out which of the arms seem to be the main ones and which ones seem to be just additional tiny arms, confirming that there seem to be only 2, not 4. Which was further confirmed by observing a lot of different open clusters detected by Gaia recently, thousands of which were mostly in those 2 arms and nowhere else. And that of course means that the galaxy very likely resembles something like this. It's a barred galaxy, it has 2 main arms, and everything else in it is much shorter, more distant, and very irregular. And actually very likely not even connected to the main structure. And because statistically it also makes a lot of sense, since this is what we're observing around us, there is of course very little reason to doubt this. However, if the scientists in this case might have missed something, and if our galaxy does have more arms, which would be very rare, it means that we have to try to find a way to explain these unusual attributes by using some of the additional observations in the future. But if there are only 2 arms, with smaller arms present somewhere inside the galaxy, the only thing we have to explain here is why exactly some of these arms split and when they actually formed. Currently this is believed to be a result of ancient collisions, but this is not something anyone can explain just yet. And so even though currently we kind of use this map to represent the galaxy, it's probably something we need to erase and redraw based on the study and the observations. But this of course does not answer a really important question. What exactly forms all of this and what guides this in various galaxies? Why do certain galaxies have certain shapes and certain number of arms, whereas other galaxies look very different? Well, the answer to that comes from a slightly different study, based on the observations from the now retired NASA's SOFIA telescope, the flying telescope that used to be part of the airplane. And in this case, what this particular telescope was able to discover basically looked like this. Over the years, it was able to create these beautiful images of various well-known galaxies, displaying actual magnetic lines inside of those galaxies, sort of showing us what all of them look like if we were to try to look at them using radio light and if we try to imagine the magnetic lines in them. And some of these images are just brilliant. But most importantly, they show us the invisible force driving a lot of star formation in various galaxies. The force that, even though we know is out there, is actually just very difficult to see. But by using years of observations of various galaxies, the scientists now believe they might have figured out how a lot of this works. And so in this recent study with the title Star Magnet, the scientists connected the galactic scale magnetic fields with the presence and the formation of different arms and stars inside of those arms. And specifically based on the orientation and the strength of the field, various types of gas tends to be funneled in certain ways, either encouraging or preventing star formation. And most importantly, in many cases, counteracting effects from gravity. As a matter of fact, if it wasn't for the magnetic lines inside the Milky Way, it's quite likely that the night skies here would have been much brighter. The magnetic lines inside our galaxy, and of course other galaxies, seem to actually stop a lot of star formation by redirecting gas into certain locations where it's sort of kept for later or used in some other way. And here's actually one of these beautiful images from a few years ago, showing us some of the magnetic lines inside the Milky Way. A few years ago, one of the major confirmations here was that the magnetic lines almost directly correlate with various large gas fields, something that usually follows the Milky Way's arms. Sometimes the scientists refer to these as galactic bones. And even though we knew these bones existed for just under a decade, there was actually no explanation for what exactly they do in the galaxy. And more importantly, there was no way to map this with enough detail to try to study this. But in the last few years, the scientists collected enough data to finally start making conclusions. And specifically the connections between magnetic alignment and the dust particle alignment in various galactic structures, with this so-called bone map revealing that the magnetic fields tend to be perpendicular to the length of the bone in various dense areas of active star formation, but they tend to be parallel in the regions where there is not a lot of star formation, implying that when magnetic fields are parallel, they essentially seem to feed the material into some other region of the galaxy, even counteracting gravity itself. Whereas when the magnetic lines are perpendicular, the gas doesn't move much and ends up forming stars. And the major discovery here is that these fields are so powerful that they seem to actually stop star formation in almost all star-forming regions except for some of the more powerful ones, thus driving the growth of galactic arms and potentially explaining the unusual shapes we observe in distant galaxies. Although here the obvious question that's not answered is what exactly forms these galactic lines and magnetic fields. It's probably because of the interaction of various charged particles, but the actual process is not really well understood, with the important conclusion here being that star formation seems to directly depend on magnetic fields and magnetic lines, especially when it comes to large-scale structures such as galactic arms. And it's the balance between gravity and the electromagnetic fields that results in the formation of unique shapes out there. So pretty cool stuff, and something that scientists sort of speculated about, but now we have official scientific confirmation. Hello wonderful person, this is Anton, and today we're going to be discussing yet another really impressive three-dimensional map of an intriguing structure created by the astronomers relatively recently, showcasing what's known as the magnetic local bubble, which basically represents the magnetic field or the magnetic structure that surrounds the solar system and everything around us, and to some extent creates this unusual shape that you see right here, that also then produces quite a lot of intriguing effects on the surface of the bubble that have only been discovered in the last few years. But more importantly, this is an actual three-dimensional map that you can interact with, exploring each of the individual parts and each of the individual structures here, with some of the individual structures, And some of these individual structures we've previously discussed in separate videos that you can find in the description below. I think one of the more important discoveries in the last few years was the discovery of this unusual Radcliffe wave that you see right here, that represents this unusual ripple-like structure that many stars seem to surf on. The video in the description explains this a little bit better. But this recent map, this recent discovery, is going to help us answer a lot of really old questions about the origin of stars and the influence of magnetic fields in various galaxies. Because this is essentially a magnetic structure. What you see on the surface here, these are magnetic fields. And so what's actually coming from this recent study is the new technique or the new ability for the scientists to be able to actually see the magnetic field on the surface of this unusual local bubble. But I guess the first question is, what exactly is this bubble? And how did it even form? Well, because we're not really three-dimensional creatures and we're more two-dimensional creatures, I love using this map that you can find in the description that sort of shows us what everything around us potentially looks like. This was created by analyzing a lot of data from the Gaia telescope. Now this is in like tens or even hundreds of light years in distance, but if you start zooming in here, you'll discover this unusual feature known as the local bubble. There are a few smaller ones here and there, but the local bubble, or the local cavity as it's also known, is one of many different superbubbles located in the Milky Way. It's potentially at least 300 light years across and could be as big as almost 1,000 light years across. And as this bubble expanded over time, it pushed the interstellar gas away from the center, which then collapsed to form new stars on the surface of the bubble itself. The star that you see moving in the middle, that's basically our Sun. It most likely entered the bubble about 5 million years ago. And so the fact that we're almost in the middle of the bubble is sort of completely by accident. This bubble existed even before the Sun entered it. But it was most likely created by some kind of a pressure from some kind of an ancient supernova that potentially was caused by one of the stars located in the open cluster known as the Pleiades, also known as the Seven Sisters. This happened anywhere from 10 to possibly 20 million years ago, and as you can probably imagine, was an extremely powerful event. So powerful that it ended up creating this several hundred light years across structure. And even though the scientists recently discovered that a lot of stars definitely form along the surface of the bubble, with the expansion of the bubble creating the pressures needed for the stars to form, there are still so many mysteries about the structure, and of course its effects on the galaxy and all of the stars around us. But in all of the previous discussions of superbubbles and all of the previous models, the magnetic field for the most part was usually ignored. In other words, it mostly focused on the pressure or on the interactions of gravity on much larger scales. But most scientists are aware that this is not the reality. As this map shows us, the magnetic field here is quite prominent and most likely plays a really important role in everything from distribution of gas, potentially guiding gas to various directions around the galaxy, or even forcing certain gas to form certain types of stars and certain types of molecular clouds. We've actually discussed various discoveries in regards to magnetic lines or magnetic fields in the Milky Way in some of the previous videos. Some of them should be in the description below. But in a nutshell, a lot of discoveries looking at all of this in radio light clearly established that the galaxies have really huge prominent magnetic lines, which potentially are responsible for a lot of effects we cannot explain. And so even though this particular supernova that happened 20 million years ago created a lot of powerful pressure, the magnetic fields that were created as a result also played a really important role. But what role? Nobody knows just yet. For example, they could definitely influence the overall shape of the galaxy, or at least the overall shape of certain molecular clouds. As a matter of fact, as I've discussed in that previous video, you'll notice that a lot of molecular clouds that produce new stars definitely seem to be located on the surface of the bubble itself. But some of them are located in the region with slightly different magnetic fields, at least based on these new discoveries and based on these new maps. What effects this has on these bubbles and how it changes the actual composition of stars and planets formed in there, that's one question nobody can answer just yet. And partially because it's been actually extremely difficult to find these magnetic fields and to study them in more detail. And so even though ESA's Gaia telescope can generally pinpoint the exact location of various stars or various really bright objects, it's not able to see the magnetic fields or anything in radio frequencies. And so instead the scientists had to rely on some of the older data from the Planck spacecraft that became really famous for creating the most accurate map of the cosmic microwave background. So it was actually able to see microwaves, which means that it was really good at looking at microwave frequencies. Frequencies that are somewhat relevant when looking for magnetic fields as well. With the data from the telescope being able to see some of the polarized light produced by various magnetically aligned dust particles present on the outer surface of this particular bubble. And in this case, the magnetic alignment of the dust particles allowed the scientists to then see the orientation of the magnetic field visible right here. And so when looking at some of the data from the Planck telescope, they were able to see all of this dust on the surface of the bubble, with a lot of the dust pointing in different directions because of the magnetic lines, which confirms an older assumption that as the bubble expands, the magnetic field seems to be swept up on the surface of the bubble and expands along with it. Which by itself is also a really important discovery, because it definitely confirms the influence of magnetic fields in galactic evolution and in star formation. And today, when using various computer simulations or supercomputer simulations in predicting the evolution of molecular clouds and star formation, most of these simulations generally ignore the effects of the magnetic fields. And not because the scientists don't want to include them, but actually because it's extremely difficult to implement them, because our general knowledge and understanding of these phenomena is, at the moment, extremely limited. We still have no idea what effects this all has on the galaxy and the production of various stars in various clouds. And so hopefully this new discovery will serve as the foundation for some of the new studies, specifically focusing on the effects of magnetic fields on star formation in various superbubbles. We probably still are not going to be able to model it just yet, but at least now we can sort of observe it, discovering what effects the surface of this bubble has on several different molecular clouds that exist around it and are visible right here. And so by trying to combine these observations with the observations of various types of star growth, we might be able to finally figure out how these magnetic fields influence the evolution of various stars, which is of course not something new and not something that we didn't know before. For example, several studies have already discovered that various types of wind shock, and of course the effects from the jet itself, dramatically change the formation of stars in just a few thousand years. And in certain systems, some of the stars get these tremendously large jets, which dramatically change what the final star is going to look like. And all of this directly depends on the magnetic fields around the star and the cloud itself. Today we're going to discuss our own galaxy, the Milky Way, because in the last few months, several major discoveries have been made about the galaxy, helping us discover a few more new things, and also helping us understand its evolution, how it changed over the last few billions of years, and why it is the way it is. With observations of other galaxies also helping us visualize what our galaxy is going to look like in 5 billion years from today. And so, hello wonderful person, this is Anton. Let's discuss discoveries from the Milky Way once again, and let's start with the center of the galaxy first, the central black hole and the region around it. And that's because one of the most recent discoveries was in regards to Sagittarius A star, the central black hole right in the middle of the Milky Way, with the new study focusing on X-ray observations coming from the central black hole, discovering its actual spin. And yeah, black holes spin, like everything else in the universe. But when it comes to black holes, it's not that the matter inside them spins, it's actually the space-time itself around the black hole's event horizon. And so here the value for the spin of black holes is usually defined as a number between 0 to 1, with 1 being the maximum possible spin. Anything faster and the black hole would just fall completely apart, and that would basically make it impossible. And so in terms of the spin of the central black hole in the Milky Way, or the spin of the space-time around the black hole, the result of the frame dragging effect, it was discovered to be pretty high, up to 0.96, almost at the limit, which is even higher than what was discovered around the black hole of M87 galaxy, the first picture of a black hole ever taken. Here the value was about 0.91, and though it's possible the value might be a little bit lower, up to about 0.86, it still seems to be an extremely high value compared to what the scientists thought before, and that of course means that the central black hole acquired a lot of angular momentum from various collisions with a lot of matter and possibly a lot of smaller black holes back in the days, maybe implying a relatively violent past. We'll come back to this idea really soon. But apart from the black hole, several other researchers also wanted to find out what's happening very close to the black hole, especially in various star clusters that seem to be orbiting around it. And here we have two major clusters that scientists are super interested in. There is the S cluster, which contains many different S stars we discussed previously, with videos right there in the description, but there's also an unusual star cluster known as IRS-13 that's orbiting around the black hole as well. And this one turned out to be really strange. It was discovered to be super young, just a few 100,000 years old, which makes it much younger than any current theory can explain. Or basically it suggests that these stars formed around the black hole not so long ago, with this cluster initially just probably being some kind of a cloud, implying that at some point the black hole captured all of this gas and through some kind of a tidal force very likely increased its total density, triggering a massive star formation, which directly explains why a lot of younger stars seem to be actually at the top of the formation and also in front of the cluster. And so along with the S stars, this basically suggests that the star formation around the black hole is definitely possible, especially when a large cloud seems to condense around the black hole, forming the density necessary for new stars to form. But this was the first time ever this was physically confirmed by observing an actual cluster. So definitely some important stuff when it comes to star evolution. But there is something else that was discovered not so far away from all of this. Basically within the central region of the galaxy. Here we have quite a lot of really surprising regions, many of which scientists really want to study, especially by using James Webb Space Telescope, with many of the scientists actually still waiting for their turn to do so, but it will hopefully happen at some point. Researchers behind the recent study in the description were able to analyze one of the nearby molecular clouds, discovering something super important in the process. Lots and lots of different nitriles, a class of organic molecules that are normally toxic, but are also precursors to RNA. And lots of them were discovered in this cloud that did not have any stars, but in essence is sort of similar to that IRS-13 cloud before the stars were formed. And so basically here they actually found precursors to RNA all over the place, which though might not sound important, is important for a hypothesis known as RNA world. The idea that suggests that all of life on Earth and potentially life elsewhere essentially originated with RNA only, with DNA evolving later, possibly completely by accident. And also suggesting that a lot of these molecules very likely did not originate on Earth. They most likely came from outer space, specifically the cloud that then created the solar system, eventually arriving to our planet through various means. And according to this idea, these clouds are probably the best place to form these molecules, which is sort of what was discovered here as well. It's only about 3 light years across, with a temperature of 100 Kelvin, and a total mass of about 1000 solar masses, but it seems to have created a huge amount of these nitriles, precursors of RNA. And so if one day stars start forming here, they might already have all the prerequisites for potential life to evolve, just like on planet Earth. So definitely a pretty intriguing proposition and a pretty intriguing discovery. But obviously, more evidence is needed still. And additionally, a few more discoveries have been made about the strange bulge in the middle of the Milky Way as well. The bulge that contains stars created anywhere from 4 to 9 billion years ago, although most of them seem to be about 6 to 8 billion years old. And so one of the recent studies, using several different surveys, including the data from Gaia telescope, discovered that there are at least 2 separate rings here, with the previously undiscovered inner ring containing a lot of very young metal-rich stars. So basically here, the stars must have formed somewhere around 7 billion years ago, potentially during the last major star-forming event, very likely a result of a major collision. Which also actually suggests that the galactic bar that's present in a lot of other galaxies here very likely formed 7 billion years ago as well, with the additional rings discovered here potentially forming afterwards as a lot of gas was flowing in from the outside. Although here it's not clear if any of this is actually connected to the galactic arms as well. At the moment it seems to be not really related to galactic arms, but it's possible that there is some connection. And this takes us to the next major discovery in regards to the galaxy, the history of various collisions. And oh yeah, there were quite a lot in the last 13 billion years. And this is actually the very intriguing part, mostly because of the way all of this was discovered and how this is studied. Here the researchers rely on something that was discovered not so long ago, the variety of various streams that seem to be located around the Milky Way galaxy. We normally call these stellar streams, and they often also contain some kind of a cluster attached to them, potentially the remnant of the previous galaxy, representing its center. But in just the last few years, so many have been discovered by various surveys. As a matter of fact, this video kinda helps you visualize all of these recent new discoveries, showing us how this looks around the Milky Way galaxy, but more importantly, connecting all of this to a lot of previous events and very likely a lot of previous collisions, because it would be difficult to explain this unless this was a result of some kind of a collision. And so here we actually have not just stellar streams, we also have a variety of different clusters. For example, the ones you see right here most likely formed with the Milky Way early on. And that's because there's a handful, or I guess a few dozen different clusters out there that seem to be really old, and actually as old as the Milky Way itself. And they all have a relatively compact orbit around the center of the galaxy. But apart from these central objects, or the ones that probably existed here from the beginning, a few more clusters orbit on the outskirts. And some of them also have different ages. And so by identifying those clusters and trying to connect them to various stellar streams, several scientists whose papers you can find in the description wanted to find out if this is basically an explanation for how they came into the Milky Way as well. And so by going through 170 different globular clusters, 41 stellar streams, 46 satellite galaxies, and analyzing their motion using the data from Gaia telescope, the researchers were able to make connections for at least 60 of them in total. In the process discovering that there were definitely several major collisions that formed all of this around the Milky Way. And you can actually see some of them in the video in the description. So we have the collection of different clusters and stellar streams from the Gaia Sausage, the very big galaxy that collided with the Milky Way, another one from the LMS-1 Wukon collision, another one from Sequoia, Arjuna, and Leetoi, a bunch of them from Cetus, a bunch of them from a collision with Sagittarius, some sort of a candidate merger that we don't really know about, and the newly discovered Pontus collision, with all of these representing separate events billions of years ago when some kind of a large galaxy collided with the Milky Way, forming the stellar streams and leaving behind globular clusters, with a handful of different clusters and streams still potentially unexplained and not connected to any certain event just yet. And in essence, what this tells us about the Milky Way is, of course, its very violent past. A lot of collisions happened in the past, at least 6 to possibly 7. Many of them formed these streams, left behind all of these clusters, and most importantly, affected the galaxy in some major ways. Including, of course, the spin of the black hole I mentioned in the beginning. The black hole, of course, very likely combined with other black holes, eventually growing larger and acquiring more angular momentum. But a lot of these collisions very likely happened billions of years ago, which is why many of these clusters and many of these streams are also quite ancient. But I guess here it was also the discovery of this new collision, currently named Pontus, that's also quite impressive. Interestingly, in this case, the stars associated with Pontus seem to move extremely slow and actually in the opposite direction. And that implies that this very likely happened a long time ago, possibly up to 10 billion years ago, making this one of the first collisions. But surprisingly, LMS-1 Wukon collision seems to contain the oldest stars, possibly some of the oldest stars in the Milky Way, suggesting that this was just an extremely ancient galaxy. And that's on top of previous discoveries about more collisions that we've discussed in some of the videos in the description. And so here one of the major confirmations is the fact that many of these clusters seem to be directly connected to many of the streams. For example, a lot of clusters such as NGC 5634 seem to be connected to the famous Sagittarius dwarf galaxy. This actually includes clusters like Terzan 7, Terzan 8, NGC 2419, and a handful of others, which all very likely came from this galaxy. Although here, a separate study also concluded that some of these clusters potentially came from many different known satellite galaxies, such as Large Magellanic Cloud you see right here. And that's because we expect our galaxy to be massive enough to capture some of the clusters from its smaller partners. And so theoretically, the scientists predict that at least 4 of these clusters possibly came from Large Magellanic Cloud, 2 of them came from Small Magellanic Cloud, and 2 more came from a dwarf galaxy known as Fornax. But interestingly, at least 14 from Sagittarius dwarf galaxy. And that's because it was much more massive and much more influential back in the days, like billions of years ago. Also confirming that 29 or about 20% of all globular clusters had properties very similar to many different dwarf galaxies around the Milky Way, confirming their origin. But where exactly the rest came from, that's not something we can answer just yet. There are still a lot of mysteries about globular clusters that of course need to be investigated in future studies. For now though, these are definitely super exciting discoveries. And then we also get an additional study that kind of shows us, to some extent, the future of the Milky Way. This is a galaxy known as NGC 7727, located 90 million light-years away from the Milky Way. And this basically shows us two galaxies that just collided, with a lot of gas warping around both galaxies and two very active nuclei right in the middle. As a matter of fact, this is one of few galaxies where we know for a fact there are two massive black holes in orbit around one another. Here the distance between them is about 1600 light-years, but one is way more massive than the other. The small one is about 6.3 million solar masses, a little bit bigger than the one in the Milky Way, but the big one is about 154 million solar masses, 35 times more massive than the one in the middle of our own galaxy. And interestingly, what we see in this image is of course a huge amount of star-forming regions. Bright with very young stars, active stellar nurseries, and at least 23 objects that will most likely form even more globular clusters, possibly explaining how many of these clusters in the Milky Way formed as well. And so in some sense, this basically shows us what Milky Way and the Andromeda are going to go through in the next 4 to 5 billion years from today, with this galaxy merging in about 300 million years from now and potentially either forming some kind of an elliptical galaxy or possibly some kind of a lenticular galaxy. And so yeah, this is the future of the Milky Way. And this is also the end of the video. We've talked about the past, the present, and the future. Anyway, we'll definitely discuss more about the Milky Way, especially discoveries from the James Webb Space Telescope in some of the future videos. For now though, check out some of the previous videos in the description. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else. Support this channel on Patreon by joining channel membership or by buying a Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.